Good morning, everyone. We'll start the inaugural session at 9:30. Good morning, Ashish sir.
Good morning. How is everybody?
Yeah, good, fine, sir. We'll soon start the inauguration at 9:30. Sharp at 9:30, we'll start.
Sure, looking forward to it.
Thank
How's everyone doing?
Thank you.
Lydia, miss, am I audible?
Yes, sir, you are audible.
Okay.
Good morning, Ashish sir.
Good morning. Good morning. How is everybody?
Yeah, good, fine,
Good
sir.
morning.
അവരോട് തുടങ്ങാൻ പോവാണേ. Rajesh sir.
Okay.
Yes.
Yeah. Good morning. Good morning to everybody.
Yeah. Good morning, sir.
Good morning.
Principal sir. So a warm morning to one and all. Welcome to the inaugural session of the AICT sponsored online adult faculty development program conducted by Department of Computer Applications, St. Kitts College of Engineering, Kottayam, Kerala. With due respect to the dignitaries, faculty members, and participants, let's begin our program. Let's begin this occasion with a silent prayer seeking the divine blessings from God Almighty. Thank you all. As the coordinator of the program, let me give a brief glimpse of the 5-day online FDP. The AACT sponsored adult online FDP titled Applied Machine Learning and Data Science is organized, highlighting the major concepts in artificial intelligence, machine learning, and data science, including the hands-on session in R language, Power BI, machine learning techniques using Python, and hands-on in AWS on ML services. We have 14 sessions in the FDP. The participants include faculty members from various universities around the globe, officials from industry, and research scholars. The major motive behind the sessions are to enrich the knowledge of the participants through interaction with eminent personalities from industries and academia. The knowledge sharing will improve the teaching learning process to the students and benefit the society. So let's start the official meeting. Now I invite Dr. Rajesh K.S., Head of the Department of Computer Applications, St. Kitts College of Engineering, for the welcome speech. Sir, please.
Okay, thank you, ma'am. President of the function, Professor Mini Punus, Member Governing Board and Director MCA, Dr. Joseph Kunjupol C, Principal St. Kitts College of Engineering, the guest of honor, Ashish Kataria, CEO, Epic Solutions, San Francisco, USA, faculty members and participants from all over India. Good morning. A hearty welcome to all of you to the inaugural function of the 5-day online FDP on applied machine learning and data science scheduled from today, that is 18th January 2021 to 22nd January 2021, organized by the Department of Computer Applications, St. Kitts College of Engineering. At the outset, I am delighted to express my sincere gratitude towards the principal, organizing team and the management for the interest shown in this topic and the support given to us in organizing this FDP sponsored by the Atal Academy ACT. Machine learning is reshaping and revolutionizing the world and disrupting industries and job functions globally. It is no longer a buzzword. Many different industries have already seen automation of business processes and disruptions from machine learning. In this age of machine learning, every aspiring data scientist is expected to upskill themselves in machine learning techniques and tools and apply them in real-world business problems. This FTP focuses on the theoretical aspects as well as applications of the machine learning in data science. The practical hands-on sessions are arranged for the better understanding of the concepts and the application of the same in real-time scenario. The speakers for the program are from renowned institutions like IITs, NITs, industries, and research laboratories. Now, let me go to the assigned responsibility of welcoming the gathering. The essence of great leadership is influence, not authority. I am very much pleased to welcome a great leader and visionary engineer, Punus George, Executive Chairman, St. Kitts Group of Institutions, in his absence here. We welcome you, sir. I am very happy to welcome Professor Mini Punus, Governing Board Member and Director MCA, who is the driving force behind all the activities planned in the department, including this FDP. We welcome you, madam. Now the chief guest of the function, Ashish
Good
Kataria.
morning.
He's an IT veteran and entrepreneur with more than 20 years of leadership experience with proven track record in digital and cloud management. Currently, he serves as the CEO of Epic Solutions, a business transformation company based in Silicon Valley and with offices in the US, Canada, Mexico, and India, focused on providing effective digital strategies for market research and data analysis. And he held positions as Vice President Sales, Sutherland, New York, USA, leading sales for enterprise professional services and support group, global head business capacity services in Wipro Technologies, and worldwide alliance director, Redmond, US. We welcome you, sir, to this function.
Thank you. Thank you very much.
I am extremely delighted to welcome our beloved principal, Dr. Joseph Kunjupol C, to this function. I congratulate the organizing team and the coordinator of this workshop, Dr. Lija Jacob, for arranging the program in a big way. But last but not least, I take the opportunity to welcome my colleagues and all the participants from all over India to this FDP. Thank you. Thank you.
Thank you, sir. It's my pleasure to invite Professor Mini Punos, Director MCA and Governing Board Member for the Presidential Address. Ma'am, please.
Thank you. Respected Principal, Dr. Joseph Kunyabolsi, our Dean, Dr. Matthew, our inaugural address is given by Mr. Ashish Kataria, Dr. Lija Jacob, Dr. HOD, Dr. Rajesh, Dr. Bikku, Mrs. Rani Sarita, and all participants. Good morning, all of you. As a governing board member, I can say that the most important resource of any institution is faculty members who teach knowledge and skills to students. We know that FDPs have proven to be successful for improving the teaching skills in higher education and to deal with the rapid changes and shifting paradigms, especially in computer education. So Atal Academic Plan help and sponsor in imparting quality technical education in the country through training in various emerging areas. So this FDP on applied machine learning and data science, it's for 5 days, and it will surely serve the purpose and hope that all participants will benefit from this program. Congratulations to Dr. Lija Jacob for being the coordinator of this program, and also Rani Sarita and HOD Dr. Rajesh, Dr. Bikku, and all staff of all faculty members of MCA Department, St. Kitts College of Engineering, for organizing this program, this workshop, and we wish you all success for this program. Thank you.
Thank you so much, ma'am. We feel honored to have with us today Mr. Ashish Kataria, CEO, Epic Solutions, San Francisco, USA. Mr. Ashish Kataria is an IT veteran and entrepreneur with more than 20 years of leadership experience with proven track in digital and cloud management. Currently, he serves as a CEO of Epic Solutions, a business transformation company based in Silicon Valley and with offices in US, Canada, Mexico, and India, focused on providing effective digital strategies for market research and data analysis. He held the positions of Vice President Sales at Sutherland, New York, USA, Global Head Business Capacity Services, Wipro Technologies, California, and Worldwide Alliance Director, Microsoft US. He also supports many nonprofit and educational institutions and sponsors innovative projects by the students. Sir, we are really honored to have with us. I invite you for inaugurating the FDP and to deliver the keynote address. Sir, please.
Thank you, everyone. Thank you, Lija. Thank you, Rajesh. Thank you, Dean and President for St. Kitts. Much appreciated. I absolutely love the opportunity to hopefully address a lot of fellow members here. I'll try to start in Malayalam, right? Ella Verum Sugantanne. Hopefully I got that right for everybody. If I didn't, then I apologize.
Correct.
But that's not a test for Malayalam today. So it's a test for everybody in terms of what you guys are doing here with the benefits of machine learning and AI. Now, it's interesting when I was invited to speak about this, right? I kept on thinking what would be most appropriate for me to share with this classic audience that probably is already doing a lot of projects in deep learning, neural networks, etc. But then I started thinking, should I go down when somebody refers to AI, machine learning? You could actually talk about a lot of topics, right? Whether it's bioinformatics, whether it's computer vision and analytics, natural language processing, predictive analytics, speech processing, quantum computing. There's a lot to digest in the limited time that I've been allocated. I'll try to make it simplified for the audience here with a different perspective, more from a business usage perspective, more from how AI in its purest form is seeping into our everyday lives. And some of the use cases that are very, very powerful, that will continue to be very, very powerful in the coming future, right? In its simplistic sense, right, what I usually say is AI is pretty much a software that writes itself, that can learn itself, that can optimize itself, that can recommend itself, irrespective of the use case that you guys are thinking about. Whether it's our daily lives changes in terms of driving. Most of you are probably aware that Tesla, the #1 electric car company today, actually with their version release 1.0 in autonomous driving, is actually already on track to deliver complete autonomous driving experience to everyone across Americas, right? And that's just with version 1.0. The current release itself essentially promises 45% reduction in highway accidents. With version 2.0, it will continue to become 3, 4, 5x times better than what it has been touted for. So within our generation, almost all of us will stop driving cars. That's a very powerful momentum from where AI was 10 years ago to where it is now, right? 10 years ago, we had AI use cases around, let's build a chess match algorithm. Let's build an algorithm that can do Go programming, right? But pieces have evolved to basically much sophisticated use cases, whether it's in driving, whether it's in home security systems. Today, as we speak, you can actually order a home security system that can analyze people walking in and out. And just by the way they are walking, just by the way they are interacting, how they're ringing the bell, the system can alert and say, does he have dubious intentions or not? Not only that, we are also getting into another classic example that we are working very closely is radiology. A lot of you guys, we are working with a startup that currently, just with a prick of finger, can figure out all the challenges that somebody could have related to leukemia, related to infections, etc., that are directly linked to an app onto a neural model that monitors your continuous blood rate count on a daily basis. As we speak today, another use case that I can share with you guys is in terms of radiology. All the expert radiologists across the world today claim that a neural trained model for tumor detection can detect 10 times more clearly or better than the world's best radiologist out there, right? So as you can see, there are a lot of cases, both from a perspective of pieces coming into our daily lives, but also futuristic use cases that are continue to get evolved. Another one that I can share with you guys is from a computer vision perspective, right? Today we can train an end-to-end training model where a computer program can completely decide a moving object down right from space all the way down to within 1 meters of a moving object. Most of you guys may or may not have heard of DARPA, the Defense Advanced Research Projects Agency, right? The Indian similarity for that is DRDO. They have a Pegasus drone, which we are working very closely with, that currently streams 1.8 billion pixel systems with 100 terabytes of data every hour, that can zoom in right from International Space Station down onto moving objects across a 100-mile radius, right? Very powerful use case that can further be extended to a variety of defense and security use cases as well. Now, the interesting cohort here is, amongst a variety of these use cases that you can go after, the point here that I would encourage everybody to take home is that AI is only a tool for any foreseeable future, right? You can think of use cases that are a bit more positive, that can work for the good of people, or you can think of pieces or use cases that can work in the destruction of people as well, right? What I would encourage you is that the advent of digital superintelligence, all the use cases need to symbiotically try to humanitarian causes. For example, one of the use cases we are working in Mexico is to completely replace, may not be a good use cases for all the professors here, but we are working to replace all the professors and have a robot teacher talk to students who are disabled, who are special, who are disadvantaged, that can recognize patterns in their learning behavior that previously a teacher cannot scale across hundreds of students, right? Cost of education can come down, disability management in students can come down, and we can really figure out a way to digitize and transform, leveraging AI, transforming the way kids are getting trained today. Another example that we are also seeing is a lot of financial areas, whether it's stock market, financial complex derivatives, whether it's identifying patterns in trade management, etc. That's already here. We are working, we continue to see constant evolvement in a lot of these use cases around financial modeling for us to figure out which banks can release loans to individuals. Are you a good is a particular individual a right fit for buying from a bank, etc. or not? Now, as we shift gears and we move towards, transportation as another industry.
In that, there is another pop-up there, like call over internet. Just click on that. Okay. If the issue still persists, just call me.
Can you mute everybody? I'm not able to do that from my side. Okay, hopefully with that glitch, we'll move on. In terms of, as I was talking about, another example that you will continue to see is streamlined manufacturing and logistics and distribution. A lot of manufacturing roles, a lot of supply chain roles, a lot of logistics roles are going to completely disappear within our generation. Whether it's with Amazon experimenting with autonomous drones, whether it's Google experimenting with real human-like robots who can replace fixing components in a supply chain floor, or whether it's Microsoft taking all of this data and dumping it onto their Azure machine learning capabilities as well. Another use case that we continue to see is shopping. Like I said, right? AI is continuously integrating into our daily lives. Physical shopping pretty much will continue to transform into complete cashierless stores. As we speak today, we have Amazon stores that are completely cashierless. You walk into the store, you can pick up whatever you want. The facial recognition technology scans your entire movement, which objects you're picking up, what's their price. They're linked to your Prime account, and you can walk out completely without ever the need of talking to a human being. Their restocking shelves are robots driven. They're counted by robots. They are reshuffled by robots. Their freshness of vegetables and fruits is tracked by robots. And last I heard, actually, that they can do a better job than our best vegetable pickers around the world onto the same as well. Now, from a future perspective, as we go along, I've given you a lot of use. I've given you a lot of use cases where I've continued to given you pieces for current seeping. As we move along, within the next 10 years, there will be no need for you to hire a construction crew. Robots will build your house within 2, 3, 5 days. There will be no need for you to hire a security guard. You would actually have robotic dogs, robotic security personnel who would walk across the parking lots, be your escorts. Your pizza delivery guy will be a drone, right? Your policeman would get converted into a cheetah robot. These are all live use cases that are going to happen within our generation as well, as we go along. So hopefully, that gives you some perspectives, guys, in terms of variety of use cases across a variety of verticals that we can continue to take advantage of. Bear in mind, the basic human needs AI will continue to solve within our generation in a much more effective way. It's going to completely transform the way we are interacting with each other, whether it's education, whether it's transportation, security, healthcare, logistics. All of these pieces are already in there. What I would encourage my fellow friends for you guys to think about is appropriate for empathy and humanitarian grounds than anything else. With that, I will hand it over to you guys. Hopefully got some perspectives on the same, and happy to take any questions if anybody may have.
Thank you, sir. I request our dear Principal, Dr. Joseph Kunyapal C, for the felicitation.
President of the program, Dr. Mini Pinus, Director, St. Giles College of Engineering. Chief guest of the program, Sri Ashish Kataria, CEO, Epic Solutions. Dean Research, Matthew Sir. HOD MCA, Dr. Rajesh. Coordinators of the program, Dr. Lija Jacob and Rani Sarda. Resource persons, faculty members. A fine good morning to all of you. Among the various emerging fields in computer science, applied machine learning and data science may be the two areas which has made significant inroads into the human life. And the applications of machine learning has been already mentioned by our chief guest, Sri Ashish Kataria. They have been useful in the day-to-day affairs of the human beings, especially for many affairs like treatment and then taking classes. This is closely associated with the program. Now, since most of the emerging nations are making use of the machine learning process, we cannot thrive. Any country, any nation cannot thrive without the application of machine learning into the daily affairs of the human society. The data science also has made huge inroads into the human life because, as you all may be knowing, say today the word data science has been a controversial affair because every day we have been hearing about the driving of data and stealing of data by various agencies. That is the importance of data science because today the machine business for the progress of a machine business as well as for the economic development, a background of a data science is required, and that is the importance of data science. And once you get the data, it can be processed according to your requirement, and that can be utilized very well in the business applications. And it is really appreciable that the MCA department of our college is organizing FDP on the two emerging fields in computer science. One is machine learning and the other one is data science. I may take this opportunity to thank the AICT for being kind enough to sanction and other FDP on this related area. And I also congratulate the computer science department, computer application departments of St. Giles College, especially the HOD coordinators, Dr. Lija Jacob and Rani Sarda for organizing this program. And I wish the program all success. Thank you.
Thank you, sir. I now invite Ms. Rani Sarita R, co-coordinator of this FTB, to deliver the word of thanks.
Good morning, all. Honorable Chief Guest, present excellencies, faculty members, participants, and my dear friends. Today, I take the opportunity to put all my gratitude into words. On behalf of the Department of Computer Applications and St. Kitts College of Engineering, I would like to thank our chief guest, Mr. Ashish Kataria, CEO, Epic Solutions, for taking his precious time out and consenting to be the chief guest. Thank you, sir. I would like to thank our Director MCA and Governing Board member, Professor Mini Punnus, for her constant support and encouragement. Thank you, ma'am. A big thank you to our principal, Dr. Joseph Kunyupal C, for his valuable support and guidance. Thank you, sir. I would like to thank all the deans and heads of various departments for their presence today. My sincere thanks to the head of the department, Dr. Rajesh KS, for his guidance and encouragement in all our efforts. Special thanks to Mr. Arun Nair, CEO Secundix, for his presence today. Thank you, sir. A heartfelt thanks to the FTP coordinator, Dr. Lija Jacob, for her valuable contribution, guidance, and encouragement in all our efforts. I thank you all the participants for showing their interest in the program. We wish you will have fruitful sections throughout. Thank you all. Special thanks to the management, organizing team, my friends, colleagues for their cooperation in making this function a resounding success. Finally, I once again thank everyone for making this program successful. Have a great day. Thank you all for joining us.
Dear all, we have come to the end of the inaugural session. We'll soon begin the session on AI in healthcare by Dr. Shamir Kadir. We'll start the session at 10 o'clock. Thank you all.
പോയാ എനിക്കൊന്നും കേൾക്കാനില്ല ഏ? അയ്യോ പോവാന്താ ചെയ്യാ പോയില്ലേ
Please be on mute.
Saying its group of institutions, the unmatched ecosystem for academic excellence. Saying its College of Engineering, the only unaided engineering college with 7 NBA accredited courses in Kerala. Saying its Institute of Management. Saying its College of Applied Sciences. Excellent coaching and personalized mentoring bring out the best in you. Saying its library showcases the gravity with which it drives the learning process. Unleash the power of learning by doing. Hands-on laboratory experiences are critical to the learning process. Sangits is equipped with the best-in-class laboratories which expose the students to the most advanced instruments, machines, and technology. Sangit Center for Innovation and Entrepreneurship fosters innovative and creative entrepreneurial activities in the campus. Our primary focus, engineering by doing. Sangit students' pioneering state-level achievements include 5 consecutive years of participation in the Baja competitions organized by SAE USA. The first ever concrete canoe of Kerala was built by our students of the Department of Civil Engineering for the competition organized by the American Society of Civil Engineers. Our students of the Department of Electrical and Electronics Engineering built the first ever electric all-terrain vehicle from Kerala to qualify for track racing in terrain vehicle motorsports. Preferred recruitment destination for many prestigious companies like Infosys Limited, Amazon, IBM, TCS, MRF, and Indian Navy. The most beautiful moments in one's life are born on campus. At Sangit's, life beyond academics is full of possibilities. The popular fests of Sangit's, Nakshatra, Synthesis, and Gits Blitz reflect the spirit of the youth. Hostel facilities for all. A home away from home. Chase your dreams. Pursue your passion and define yourself at Sangit's. We at Sangit's believe that greatness is already within you. We will help you bring it out because we are equipped to do so and we genuinely care about you.
What are the features you are considering for a flower detection?
Sangit's
Samir sir, am I audible?
I can hear you loud and clear.
Okay, sir. One second. Dear participants, now we have the session on AI in healthcare by Dr. Shamir Khader. It's my privilege to introduce the eminent speaker to the participants. Dr. Shamir Khader is a Senior Director, Data Science, Digital Health, and Bioinformatics in AstraZeneca, a global science-led biopharmaceutical company in New York, USA. Sir has a strong domain experience in pharma, biotech, medtech, digital health, precision medicine, and drug development. This data science leader oversees a portfolio of projects in oncology and biopharma to accelerate drug discovery and development using biomedical and clinical big data using machine learning approaches. He obtained his PhD from National Center for Biological Sciences in India. He has published more than 75 peer-reviewed research papers and 80 conference publications in the area of pharma informatics, healthcare, data science, bioinformatics, drug discovery, and precision medicine. Various national and international media, business, biotechnology, and science publishers have featured his work. His work was featured in media outlets including Forbes, Fast Company, Bloomberg News, Times of India, The Indian Express, Health IT Analytics, etc. His work was also featured in the blogs around the world and includes blogs by MedGadget, UNESCO, etc. He received multiple awards for his bioinformatics and biomedical research work, including Eli Lilly Asia's Best Thesis Award in 2011, BioClue's Bird Award for outstanding contributions in the area of bioinformatics and functional genomics by an Indian origin scientist. He received several grants and fellowships from funding agencies like National Institute of Health, National Science Foundation, Department of Biotechnology, India, and Wellcome Trust, UK. He was an elected member of 50 Health Information Technology Influencers of 2015, one of the 16 data scientists making vital breakthrough in healthcare in 2016, and in 2018 he was recognized as one of the 100 artificial intelligence leaders in drug discovery and healthcare. His work on developing on open catalog of drug repositioning has won the Swiss Institute of Bioinformatics Resource Innovation Award in 2017. Sir, we are really privileged to have you with us. Welcome you to the session. Over to you, sir.
Thank you, Dr. Lija, for the nice welcome. Just trying to figure it out that the host disabled the attendee screen sharing. So can I get the screen sharing?
Sir, we'll do it soon, sir.
Thank you. My apologies for the bad lighting. I'm right now in the US and it's like 11:36 p.m. And yeah, I'm using some lighting to fix that. So let's go right here.
Please. Okay. Yeah. It's visible.
I hope you can see that.
Yeah.
Right, and then. Okay. So thank you, everyone. And can you see my main screen or the sharing screen? Let me just swap the display. 1 second. Yeah. Now it should be fine. So yeah, hi everybody, and welcome to this session. And before I get started, I want to thank Dr. Lija Jacob for making all of this happen. I used to give FDP talks a while ago, so it's really a special session. It's kind of meeting with the teachers, professors. It's a very unique opportunity. And first of all, I want to thank Dr. Lija Jacob again for this unique opportunity. Definitely the sponsor of this activity and including the St. Kitts management. With that introduction, I'll get started. So before I get started into the details, so I just wanted to kind of give you a bit of an overview on what I do. And this is actually a drawing that my daughter created a while ago. I do something with data. So that's what her, thinking about my career, day-to-day career, I work with some kind of data. If you ask, some of the major media outlets, they think that my job is considered to be one of the sexiest jobs of the 21st century. But what I really do is actually a combination of computer science, information technology, and then combine that with maths and science, and then I apply it to a very specific domain in life science, biopharma, and biotech. And then there is a new term for this, like we call it data science, and it's empowered by 3 other pillars, as you can see here, empowered by machine learning, classical software engineering, and of course, strong traditional research methods as well. So that's what I do. And in terms of my background, I always take a minute, and thanks to Dr. Lija for that great introduction, I always take a minute to kind of share where I'm coming from. So I did my undergrad and master's in Kerala. So I did my PhD at NCBS and in Bangalore. I was affiliated with TIFR, Indian Institute of Science. Was also trained at Mayo Clinic and Mount Sinai, and have more than 10 years of career across different medtech and healthcare companies in the United States. And you can find me, if you want to interact with me, I'm on almost all social media platforms out there. I'm available on Twitter, I'm available on ResearchGate, BioStars, and recently I gave a TED Talk to, so if any of you are into that type of content, you can find me on YouTube as well. And just as a disclosure, I don't have any conflict of interest for this particular session, but there are a few things that I need to disclose. And I'm currently a full-time employee of a company, a global biopharma company, AstraZeneca. And before I get started with, I wanted to kind of give you a public health relevance of this session. So why is it important to look at big data in healthcare? Why is it important to look at, apply machine intelligence to healthcare data? In the end, if you use them in a correct way, in a more fair way, data-driven methods that use AI algorithms and real-time data in a hypothesis-free approach, we can potentially find, better drug targets, better therapies, making sure that a patient receive right type of care at the right point of time in this care plan. And then also there are a variety of strategies to develop predictive or prescriptive models, and they can actually accelerate the identification, access, and delivery of therapeutic strategy for patients at risk. And this collectively has a major implications for improving the value and evidence of novel and repurposed drugs as well. Just to summarize, the broad public health relevance of this session would be that application of AI in healthcare will ultimately optimize care, reduce cost, and improve patient outcomes. So that's what we are trying to do here. And over the next hour or hour to 15 minutes, what we wanted to do is want to kind of go through a bit of few sections here. We'll talk about what is AI in healthcare and why AI in medicine. We want to understand that why, how, and what of that. And then we'll look into a few toolkits and methods that's available. We'll talk about a few applications that we have. And then I'll finally introduce a framework for AI in healthcare. So if you go back to your students, you could design your own AI experiments with healthcare data. So that's what I really wanted to do with this session. And then we'll also talk briefly about its context in the setting of India, and then also some future directions and conclusions as well. And before we start with, let's do, I'm sure many of you are now, teaching faculty, you already know this, you'll be teaching full courses on data mining or, predictive intelligence or, artificial intelligence, but there could be, faculties from that not actively working on this here. So I want to kind of take a moment to do some level setting here. So I have a brief definition of big data here. And when I refer to big data, it's extremely large data set that may be analyzed to understand patterns, trends, associations. And you can also develop predictive models using that. And then for that particular aspect, we use predictive analytics, a suite of techniques. It's a subdomain within data mining, and that can be used to forecast probabilities and trends, which is, again, heavily used in healthcare as well. And then we saw what is data science already, and I'm not going to talk a lot about that here, but we'll see different examples where all these different streams of knowledge would converge at one point of time or the other. And AI is wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. And then a smart robot is having some kind of AI. The phones that we use have some kind of AI, and then we see AI in our, sort of day-to-day life. If you take a picture of a flower, we have an app that can tell you what flower is that, because that program is now trained using hundreds of thousands of flowers, and people have done annotation and then that classification, and then they train the system to do that. That's one thing. And then like that, if you want to build a medical system also, you can basically apply that same technique. You can show somebody with a tuberculosis disease and somebody's X-ray with the tuberculosis disease and no tuberculosis, and then you can build a machine that can understand it. So what we really do here, for example, in AI in healthcare, collectively it refers to the application of AI approach to improve health outcomes. That's a one-line definition. We want to improve health outcome. That's why we are applying machine intelligence, AI, or machine learning to this type of data. And then application of AI in healthcare includes a variety of examples, like improving diagnostic accuracy, develop precision, drug development strategies, deliver right therapy to the right drug at the right time to a patient with optimal efficacy and least side effects. So that's what we are really after this. So it's a large amount of methods. You name the latest and greatest method in machine intelligence or machine learning, I can show you an example of that applied in healthcare. So it's a very fast-moving field. Often, when machine learning scientists discover a new method, they try to look for healthcare data and they apply that. So that's why it's very, very important. And let's look at a few key application areas. Like, if you look at the AI timeline, and I'm sure everyone have a different versions of this timeline, and we are now in a stage where right now we have AlphaGo. Even right now, one of the companies that work in fundamental AI already did a problem in biomedicine recently. So you may have heard about the company called this particular company that solved AlphaGo recently solved protein folding problem with the highest accuracy, which is one of the grand challenging problem in biomedicine too. They applied some of their deep learning approaches to the problem of protein folding and found a better way to solve that problem as well. So there are, it's, I often, when I talk to students or, especially I talk to younger students, they say that, oh, there's a hype around AI, what do you think about it? But I would say, no, it's not about hype. AI is now getting mature, because I still remember back in the days when I was a graduate student in CBS and IISc, I had to go to Pune to run some of my machine learning experiments for the first time ever in the campus, because no one has done that back then in the campus. So then I went to Pune to a course, learned that, I came back, and then, I still remember that. So it took us, from 2000, that was back in 2004, 2005, you think about it, like 15 to 16 years it took to really mature it out. So I would say it's much matured. And then you can see different classes of AI too, like, whether it's interactive AI, you can talk about, whether it's your Alexa or your Google Chat or your Google Pay app. So they're kind of some kind of interactive AI. We have text AI, we have functional AI, whether it's IoT or robots. And then you can also do sort of an analytic AI, whether it's sentiment analysis, supply risk analysis, and then also visual AI, just the flower example that, or the tuberculosis X-ray example that we talked about. So it's a fairly large area, and then it's actively in developing. Almost every other large corporation is investing into it, because it can ultimately accelerate your business, whether you are in fashion, in retail, in health, in automotive, doesn't matter. You can now use these group of algorithms, group of these methods to improve your business and the business outcome. Or I'm primarily interested to apply it to healthcare only healthcare. So that's the scope of my talk today. And then within the field of artificial intelligence, there are like subdomains. Of course, machine learning is one part, deep learning is another. And then if I just to kind of refresh our background on this, like why and how this is different. Like whereas a traditional programming, you put in your data, your program, the computer will run, whether it's a compiler or interpreter, run that, you get an output, you're done. Whereas machine learning, you take that data, you take that output, and then you give it to the computer, and then you in the end you get either a model or a program, and then that program can now do that similar task on hundreds of thousands of examples. So that's one of the fundamental difference. And there is a plethora of algorithms now coming up. It could be either in supervised or unsupervised or reinforcement learning, or even with deep learning, there are a wide array of algorithms are now available. And then now let's, with this background, now let's go back to healthcare here. Healthcare is all about all of us, and we often feel lost and overwhelmed. I'm sure we all been to these sessions, maybe they're not available. Our favorite doctor is not available during the weekend. Some of us have insurance, some of us don't have insurance. We don't know, who provides the best, who's the best cardiologist in your neighborhood. We don't know those information. And then, patients often, avoid healthcare because it's confusing. People say, okay, there is, for every drug, there is a side effect, and then sometimes doctors don't coordinate your care. We always feel rushed. Oh, like, we wait for 2 hours and get to see doctor only for a few minutes. It's a very, very personal and very important to us. And then it's not just about that part. It's a significant part of global economy. And then whether you are, whether it's covered by government funds or covered by independent out-of-pocket expense, it's a significant part of expense of our global economy. You take, for example, United States, we spend 8.3% of our GDP. In India is now around 2-ish. Hopefully it'll increase soon. So this is an important part. But we all know that there is an improvement in technology, right? Like we all know we use these days, like, think about the old telephones we used to use, and then now we have cell phones with all of us. I mean, almost everybody is now connected. But why we are not seeing that type of technological advances in medicine? So this is one example, like how spending by medical condition is increasing in the United States. As you can see that this is not just a US trend, and we can bring in India too. I'm sure this will be almost, in a similar, there'll be like good correlation with that data as well. But now let's go to India. If you take independent states in India, the average expense of hospitalization in Delhi is $30,000, 30,000 rupees. And then we also have this percentage using public hospitals and percentage using private hospitals. And as you can see that the cost of care is increasing. And by 2011, we were hitting almost 2.7 trillion in the US as well. So it's a significant part. So now let's take a moment to think about it. Why this is taking this sort of complex expense and then also taking a lot of time to do that. So let's go through one simple example here. Yeah, it's not a simple example. Let's look at one example here. So let's assume I'm a patient. I'm going to see a doctor. I need I need blood pressure medication. It's very simple, right? But it's not that simple. For example, there are a variety of different classes of blood pressure medications that are available. This particular cardiologist that I'm going to see is seeing me for the first time. He took all my vitals and he looked at my blood pressure. I need a medication. So he recommended, based on his experience, he recommended a medication to me. But then what happened is that the first medication that's been given to me could be not the best one. There could be, maybe he referred a beta blocker to me. Maybe I should have been ideally on an ACE inhibitor, for example. So now what happened? That's our standard of care, be it India, be it in the US. That's how we are now practicing medicine. But where we want to be in is we want to move cardiology from a standard of care approach to precision cardiology. So now we can measure who is the best match for which drug. We have that. If you do a small blood test, we know whether we would be best fit for a beta blocker or ACE inhibitor. And we can use that information. We can use a bit of machine learning and then use what we call as a data-driven disease subtyping and patient stratification. So that what happens here is that each of these, instead of pulling us all as one whole group, we can divide our patient population and assign that right drug to that right patient. So that's an excellent example where we want to be. There are examples like this exist right now, but it's not applied across. It's not just a global health practice right now. But then what we hope is that if we have the right amount of AI applied to solve these type of problems, we will be able to get there. That's the hope, and that's where we're working towards. And really, we want to try, move from a try and switch approach to more personalized and data-driven healthcare delivery. That's what we wanted to do. And then, if you think about it, what are the major application area and challenges? You can diagnose. If I summarize them into like three main areas within just the healthcare: diagnosis, interventions, and outcome assessments. The diagnosis: what is the disease? And and what can you do about the disease? That's the intervention. And then outcome is, if you do that, and for a given disease you've applied this given treatment, what would be its outcome going forward? So these are the three main area that you should be thinking about. And then there are like different examples and different variations of that as well. So now I want to take a moment for all of you to think about this. Have you ever thought, being engineers, I'm sure most of you have training in engineering and I'm sure in technology, and some of you might be coming from electrical or mechanical engineering. So we have automated cars, but what about seamless healthcare and wellness? Have you ever thought why we don't have an automated healthcare system? Or if you all know, there's the car brand called Tesla. They're now they have automated cars out in the market now. And why we don't have that? So I want some of you to kind of put some of your answers in the chat box, and then we can definitely do some interaction. So I want everybody to take a 15 seconds break and then to type in your answer. I just want to know, what do you think? Why we have automated cars but we don't have seamless healthcare and wellness? What would be your thought on that? Yeah, please go ahead. I can see some of you typing, but please go ahead and give your idea. We'll take a few more seconds. You can see some response. Okay, keep it coming. So we have seen there is a significant challenge, right? Like now with the examples that we discussed, we are seeing that there is a significant challenge here. But what I wanted to do now is that to enable each and every one of you who, to kind of think about this problem a little bit more deeper, a little bit more from a technical side, and also think about it from, okay, maybe I should collaborate with the hospital, as part of my university. Maybe I should go and collaborate with this really nice cardiologist in the area. Maybe I should collaborate with this oncology hospital in the town. So I want all of you to kind of think about that. Be multipliers of healthcare data science. That's what I wanted. If some of you become that, I'd be really glad. So that's what we're going to do. I'm going to really show you how to do this with a few different examples. Okay, excellent. So now, we talked about the problem. You all understand this is a challenging problem. We definitely need a lot of different collaborations to solve these problems. We need somebody with the mindset of an engineer, mindset of a physician, mindset of a scientist, mindset of an analyst, mindset of a data visualizer. We need all of them. But it all starts with one thing. It all starts with data. You need good data, or even bad data. Doesn't matter. You need data. You need data that's big, that's small, that's data crumbs, fat data, thin data, you name it. And I'm sure many of you have seen this before. You take any of the world's leading magazines, you can see that they've had an actual cover issue on big data. The timeline might be a little bit different, but I've never seen any technological trend having something like this. Why is this important? Because the data is important because it's in a way, it's our history written in one way or the other as it happens, right? Like, whether let's take your example of your cell phone, for example. Google knows much more about you than your physician, right? Like they know how much time you spend on the phone, how many times you're opening it. They know the kind of, the content that we consume. They know whether we are running, walking, or slouching in the couch. All of this information they have. And they know how to make YouTube the most interesting app by showing you the kind of video that we like, each of us as individuals like. Why? They do extreme personalization, in my opinion. We need to apply that sort of tech using the data that we can get so that we can deliver better healthcare. So data is extremely, extremely important. And then what happens with biomedicine and healthcare is that there is an exponential growth. And we are handling large amount of data, TB or even PB level data. If you look into some large companies, they're generating a lot of data these days, whether it's a patient data that's coming from something called electronic health record. It could be something that's coming from public databases. You might have heard that SARS-CoV genome sequence, like 300,000 genome sequence. All of this data is now saved. You can also go in and analyze them. And similarly, a lot of human genomes are being sequenced. If you want to understand how your cancer is behaving, you can sequence your genome, look into that, and recommend drug for you. But then, can we have this in a more affordable way? Can we have this in a more accessible way to everybody? That's where we are thinking about. And speaking of cancer, for that matter, the cancer, we do have cancer therapies available for a lot more cancer than we used to have. Like whether you take 10 or even 5 years ago, we now have therapies for most of the cancers out there. If you take into just the raw numbers. But then really why there is a data-rich innovation is because of biology. When I say biology, we now have more ways to look into your blood. We have more precise way to look into your measure different components within the blood. So there are like a lot of different profiling technique, whether it's a genome sequencing, metabolomics. We can look into the bugs or microbes within our gut. So there are tests available for that. We can have either an Apple or a Google Watch, for that matter, any smartwatch. It can measure a lot of health data for you. So if you put all these data together, we might be able to leverage AI to improve healthcare. And then what happens is that the real challenge here is that in biology, this is not new. And like I said, I'm a classically trained bioinformatics scientist. Like that's how I started my career. And then in that time also, like we were when I was at NCBS, IASC campus, we used to have one of the largest computing cluster in the country. So I was fortunate to work on those in 15 years ago. So now everything is, in a way, cloud computing, or you name it, you can scale it, you can pay as you go. All of these options are available now. You don't need a cluster computer to do any of these analysis. You can, if you have a credit card, if you have some kind of a research fund, you can easily spin a cluster, a high performance computing infrastructure and do this modeling. So what happens is that we live in a world of growing population, and new diseases and resurgence of old diseases are happening. And what happens is that, on the other side, data is cheap and almost readily available and reusable as well. When I say reusable, I can ask a question with the data, you can ask a different question with the data, and the data is still there, right? That's really, really, really awesome. So it's a what do you call, a reusable resource, unlike anything else we had. And we are going to hit it, by 2015 around 9 billion in population. We, on the other hand, we have challenges like coronavirus, which no one was expecting. And with that, I wanted to kind of bring, so there are different data sources access. I wanted to tell you about a few of them, and then we'll see a few tools that we can use. So electronic medical record is primary human health data harvesting interface. So you might have seen that when you go to the hospital, I moved to the US almost 11 years ago. We used to have like charts, but still there was some kind of, patient intake software and all was existing even back then. But now, last year when I went, everything was actually, digital and fully connected. And, I remember it's quite surprised that you get an SMS to remind you that your lab test is available. And then your lab test was available as a PDF. That was the advance that we don't have here in the US at this point of time, not yet. There are certain restrictions on that, but anyway, so India has kind of moved really fast in that space actually. So, but then electronic medical record is a fundamental tool for us to capture human data. Like, it has its own challenge. It's not the perfect solution, but what happens is that this resource is in a way contain a patient's medical history, patient's diagnosis, a medication, treatment plan, immunization, allergy, radiology. So if you have that information saved somewhere, and that can be, accessed using, in a more, privacy secure way, we could basically learn how patients behave and what works for a large number of patients, right? Like, the dream is really to have, if a patient is sitting in front of a physician, can we have a system that can show 10 patients like this that ever been to this hospital and who had the best outcome? Is this patient similar to that patient or far from that? Or we need a all new different work plan, like a care plan for this patient. So really, that's the gist of getting there. But the EMRs are not that advanced at this point of time, to be honest. But right now, it's just a data harvesting interface. And I want to kind of introduce you to one of my favorite scientists, Dr. Atal Pure. He's a pediatrician, he's a health informatician, he's a computer science undergrad, and he wrote this really nice piece in journal, one of the most respected scientific journal in the world, that a deeper understanding of disease requires a database of human traits and disease states that is integrated with molecular information. And this was in 2008. Remember that? I was still I was still doing my PhD back then. So then I was really motivated by this, and even though I couldn't work with him, I ended up working with somebody who was his from his group, Joel Dudley, and obviously had great time interacting with Atul as well. We collaborated on few projects. So if you wanted to work with, this is I just wanted to kind of give this as an example. If you really want to work with someone, just or to solve a particular problem, you'll eventually do that. There's no one stopping you getting what you wanted. So really coming back to this one, the ultimate model organism is humans. Like if you want to cure human disease, we want to study humans. But then he kind of laid out this beautiful vision. But now we have, in a way, that type of database exists. And then, while in India, this type of resources are not available everywhere, but they are starting to come in actually. For example, there are different types of databases that we can use. now you can go in and download data from something called a UK Biobank. This is a United Kingdom's UK Biobank. You can send a request. You want to do machine learning model about this disease. You can download that data. That includes their genetic data, their phenomic data, their clinical data, imaging data. You get all of that. And then you go to, there are like biorepositories, and biorepositories are available. Let's say a cancer biorepository would be available in different parts of India, for example, or around the world as well. And then there are different, like that, there are different data sources from which you can take data. And then that's one of the primary sources. But then on top of that, now everybody's now wearing one form or the other of a smartwatch or some kind of digital pedometer or things like that. All of that data is going to be useful. You might have heard news that Apple Watch saved somebody's life. How? Because they showed that someone having a particular cardiac rhythm that could lead to a condition, and then instead of detecting that much later in life, somebody can see that right in their arm. The condition is called atrial fibrillation, and then they can seek medical care. So the way we were doing medicine is now changing, and there are plenty of data available, and a lot of data is available in the public domain as well. Now, this data is not really, coming in a very clean format. Often, these are human-generated data. Data would have a lot of errors and all. But what has been done in the medical field is that we have developed certain standards. How do you pull certain data? How do you integrate data with other types of data? There are certain standards available. For example, protected health information is a particular standard. Any patient-related information, including information about the provider or payer and other data that can be linked to an individual, this is not readily available. And this is extremely important to protect a patient's identity. And then also, as you can see, a lot of different data sets and data standards and ontologies available. And as you get into one or the other type of data, we can use them to improve or to gather a lot more data from these resources. Can you hear me? Is everything okay? Okay, and then
Yes.
the other part is that we can also leverage what we call as the along with this type of sensors we talked about, we can also use digital biomarkers. So let's say if I can get number of kilometers a person walking per day, steps climbed, and the running distance, I can use that information for a lot of different applications, like movement disorders, rehabilitation, epilepsy, and myalgia. So these are the different ways I can take any of this clinical information and then potential digital biomarkers and then correlate that with clinical information as well. So what's happening right now, just like you have IoT in engineering space, we have medical IoT or healthcare IoT in biomedicine and healthcare. Here, what happens is sensors are cheaper and real time and provides far more data than a typical hospital visit. So they are becoming even more important these days. And then if you go to, so we saw a lot of different type of data. Now let's look at, you might be thinking, okay, we have a lot of data, we have a lot of standards. We now need to put this in a data model. And I'm sure most of you are familiar with the data model, especially coming from computer science and IT. And then, it's nothing but a way to organize different input and output data. And then one of the models that we have developed is this called as individuum, how you can bring different data, whether location-specific data, health monitoring device data, and then electronic health record data together, and then use them to improve, actionable recommendations for a particular patient. And I can tell you one good example for this would be, is a patient living in a place with a lot of climate allergy and then, low walkability, and if that patient is asthmatic, we can potentially detect, asthmatic triggers from that data. And if let's take a blood pressure patient with blood pressure, if that patient is doesn't get all that, walking 6,000 or 10,000 steps a day, or his diet is poor, and then, maybe, we could have some kind of way to engage with that patient and improve the behavior. So these are the different ways we could interact with our patient using a data model like this. I don't know why there's that yellow color. I don't think I have a way to fix that, but anyway. So what we were primarily talking is, we introduced the problem, we talked about the data, and then a good sort of comparison between the two is here. So, in the traditional medicine, we were talking about traditional data types, but in AI applied data-driven medicine, if we are talking about evolving data types. This medicine was centralized, but here it's decentralized. We were talking about GBs or TBs of data, and then if you go to this side, we are talking about petabytes and exabytes of data. More data was structured. Now we can bring in structured, semi-structured, unstructured data. A data model could be, doesn't have to be stable. We can bring data from a variety of resources. Could be from imaging, could be from streaming data. And then we were primarily using statistical approach. Now we are using machine or deep learning approach. And we'll see a few of them today as well. And then when we run these type of studies, for example, if we want to understand what mutation is associated with a particular type of cancer, we were looking at very small number of patients, but these days you can look into large number, tens of thousands or even 100,000 patients in a given study as well. This hypothesis driven, now we are moving to a data driven as well. So these are some of the key characteristics where we can kind of see that evolution as well. So we have seen what AI in healthcare could do. We have seen what data type that we could bring in. Now let's talk briefly about different algorithms. So can we all think of a machine learning algorithm that now that you've learned AI in medicine, you have seen a little bit of different types of data. So can I ask you all to type in either your favorite algorithm or what algorithm would you apply to these type of problems? Anything. It could be from machine learning, could be from it could be from pattern mining, doesn't matter. So what would be the type of algorithm you apply to solve this type of problems? Could be even your favorite algorithm, doesn't matter. Or you've seen a little bit of data. We have streaming data, we have imaging data, we have EHR data, we have patient history. What type of algorithm would you apply here? Or what type of technology would you use here to solve these problems? Okay, keep it coming. I can see a few of them already here. Very nice, thank you. Okay, so yeah, so now let's get into, we've had enough examples of data. Now let's look into the actual technology landscape. So what's happening in technology landscape? We're seeing a lot of activity here, right? So I told you every modern machine intelligence, machine learning, artificial intelligence algorithms are being applied. You can see that, there are a lot of concepts where a lot of, whether it's NLP, whether it's text mining, whether it's NoSQL, you've already seen some example of data model, data governance, security, you name it. All of these are being applied in this setting actually. Now, if we go to, if somebody asks me what could be the technology stack, so this is it's a bit, it's from one of our sort of review article we've written a while ago, and then this pretty much stands pretty good. So, you need some kind of distributed computing for batch and streaming data processing. So you can use a bunch of Apache resources, and for big data, you need a data storage, right? Like, whether it's MongoDB or Neo4j, Elastic, or, whatever that you wanted to use. Neo4j is, for example, a graph database. For data visualization, you can use a variety of data visualization tool. I'll also talk about one tool that we developed. And then, for deep learning, talking about Theano and TensorFlow, like I said, now we have even other packages and methods available. And then for machine learning, obviously, you have, of course, TensorFlow and other type of applications available. And one thing I can tell you, like, I started machine learning when there was none of these available. I know I'm kind of that old, but none of these were available back in in 2004, 2005. We're talking about these are much recent projects. I'm really glad to see the breadth of tools available right now. So if you're teaching and looking for modern toolkits, this slide could be available. I'm sure I'll share the slides with Rilja as well. And then even if sometimes may not be in the in the syllabus, but you could still refer them to some of these modern tools as well. And nowadays what happens is that all the resourcing is kind of going to different cloud computing resources. For example, if you are within AWS or Amazon Web Service, you primarily use that set of tools. If you go to Microsoft Azure, you use that. If you go to Google, use that. But then, we don't have to confine to one cloud service, because we are kind of moving from that single tenant, single cloud service to sort of a hybrid cloud infrastructure, or the future is going to be hybrid cloud, because just like you pay for what you use, computing scenario, we can pick and choose the best one out of different vendors out there. So these are the technology stack as well. Now let's look at two simple examples here, like what, if you wanted to do clinical text mining and medical NLP, what do you do? So a very simple example here. So there is something called nursing flow sheet. So this is basically each nurse will have a set of information that they collect during their, let's say if a patient is in the hospital. And then what we have here is different ways that nurses describe a patient's neurological status. So there are different, patient responded to the, to the call, to his name, but patient counted up to 10. So that you can, as you can see, that the long list is different, different terms, different, phrases they have used to define that. And if you need to do some computing in the end, for us to do some actual, prediction on that data, we want to convert that into something called an AVPU scale. And as you can see that, 300,000 of them were alert, around 46,000 of them were on voice, and 60,000 were on pain. So we had a variety of different terms where we matched. So it's a simple example of that. But when you come to a complex medical NLP or natural language processing, so you look here, so that we have different concept classes here, and then we are using a text processing approach. You've trained the system over 300,000 clinical notes. You have a tagger, you have terminology. And then what happens is there's a system developed at Stanford. We have applied that to some of our data set. And what we're doing here is that Mr. X represented to the Santa Clara Valley Medical Center emergency room with a complaint of left side chest pain. So and you can see, X presented is an unplanned event. Which locations? It's an emergency care facility. And where is he now? Right now, he's in an emergency room. What happened to him? He had a left side chest pain. So like that, you can take a complex text, convert that into what we call as a data matrix, and then use that data matrix to basically run your computing on. So this is a sort of an example for that. And now we've seen an example of this one. Now let's go to something that we've developed internally for some of the users. So we wanted to build a visualization toolkit, and a visualization toolkit for visual analytics for electronic health record data. And then what we have done was that we primarily wanted to extract data from electronic health record, extract data from like wearables, and also like extract data from different resources that's available. And then what we wanted to do was we wanted to do with some type of visualization in a very complex way that electronic medical records were not doing back then. And this is also, again, a work that's published in 2016, but still relevant. A lot of people use this, and their code and everything available in the public domain. I would encourage, if you're interested in a biomedical high fidelity data visualization, I would encourage you all to kind of take a look at that as well. So that's one part. And then it also kind of brings to a data integration problem as well. How do you integrate different types of data that's coming from these resources? So we've done some work on that. And then use that data to build large-scale software systems that can do real-time modeling and predictive analytics. And then there is also a concept these days called data lake. So we've spent some time on how should we design a data lake for that. So this is more of an architecture. So if any of you are into system architecture, system design, again, another nice problem that you could also work with some of the health hospitals or health clinic within your locality. Or these are some of the ideas that I want to kind of share with you. And then when it comes to algorithms and methods, so you've seen a lot of tools and algorithms, and then I wanted to kind of give you an example here. Really, what I wanted to show is that we use the same set of algorithms. There is no specific class of algorithms here. We are also using the same set of machine learning algorithms. We do bagging and boosting, and then do random forest. We do support vector machines, and we do neural network, we do reinforcement learning. And then, as you can see, a lot of these algorithms are applied to solve problems in biomedicine. For example, whether it's supervised or unsupervised. One good example is that deep learning applied to ultrasound image processing. Pulmonary embolism diagnosis. It's a very, very risky disease, and very difficult to diagnose. And they use something called topological data analysis to do that. So that's, again, another type of algorithm that's out there. And then, whether it's ensemble network, a random forest Bayesian network, same set of algorithms that you are familiar with, that's being applied to solving these type of problems. So I want to kind of share with that. With that, now you've seen the problem domain, you've seen the data, you've seen the algorithms. If you have given an opportunity, to what disease would you apply this? I need some answers on that. You can type in the text box. And let me see why there is this markings here. Let's take a minute, 30 seconds for that. Like, to what disease area would you apply all of this if you have an opportunity to leverage machine intelligence to solve a problem? What disease area would you apply? Okay, it looks like I cannot really change that. Maybe not me. Okay, we got a few answers. Thank you for that. So what I'm going to do now is really to take you through a few examples where I was fortunate to apply these techniques to solve some of those challenging problems in the field of biomedicine. And then what we have here is that, if you take this, overall artificial intelligence in healthcare, there are different areas where we could apply this to. You can apply this to improve diagnosis, improve therapy selection, improve your research and development, clinical practice, population health. And along with that, a lot of other things too. You can optimize the resource allocation. So, you can use these sort of predictive modeling to, do continuous monitoring of patients. You can use this information to extend physician efficiency and efficacy. You can bring in a lot of different type of data and then do modeling. And then precision disease stratification. Remember the blood pressure medication example we have seen in the beginning, like that. And then also in the end, like, you can also find new drugs as well. So there are different ways, different applications that we can use. And these are some of the problems that we have solved. So I guess, for example, you can predict staffing requirements. And then, if you have an optimized staffing requirement prediction, you could save, some savings for the health system. You can predict, who's going to be sicker over next 4, 6, or 18 hours, and then you can escalate care for them so that you can save actual patient lives with that. And then, sometimes, your patients may go back to home, or sometimes they go to what you call as, extended care facility. And then that assignment, if you do properly, your patient may have a better outcome. You can do that. Or you could use these type of algorithms to do repositioning, drug repositioning, and recommend drugs for diseases like Lassa virus, Nipah virus, or even coronavirus. Like, there are more than 120, or right now maybe even more than around 200 different studies on repositioning have reported for coronavirus. So a lot can be done with this approach. And with that in the mind, like, we talked about, a lot of things, not all the different types of data, but still we covered a significant amount of data today. I want to talk about 3 things. Like, I want to give you an example on EHR mining. I want to talk about an example on computational diagnosis, and then one on repositioning as well. So this is what we're going to see in terms of examples. And then we'll open up for questions as well. So AI in healthcare. So we'll start with what we can do in EHR mining. So you all know now what is EHR. We'll have a patient's clinical history and what the medications they are taking, what diseases they have. But then what we can do is that we can construct the disease trajectories with this data. So we've done a work in this space. What we've done is that we have taken, for each disease, we built what we call as a disease pair. So disease X, and then you get disease Y. Sometimes what happens, disease Y, then C. And then if you have that connection, you can build what we call as a disease trajectory. So for example, if somebody is, at 40, diabetes, is he next getting, I don't know, is he getting a cardiac condition next, or is he going to get a neurological condition next? So that's actually hiding in the data. So we developed a system to kind of look into that type of data. We analyzed them for almost 1,200 disease, almost 1 million patients. And then we also did this across 3 different self-reported ancestries, because whether it's a European American, African American, or Hispanic, Latin, and we built this data for more than 37,000 different disease pairs. So we often talk about big data, but here is an ideal example of what we can do if you have access to de-identified, privacy, safe type of data set, what we can do, what kind of questions we can ask from this data. So we build this data, and then as you can see here, I'm going to show you an example here. So what we have here is that we have disease trajectory for neurological conditions, and the red dots in the figure, I don't know how visible this is, but these are starting from sleep disorder, it's go to adjustment disorder to, it goes to dry eye syndrome, like that. That's the trajectory. So you can literally see what's happening. So each one of these are for different self-reported ancestry. So that's for one. Whereas here, start from sleep disorder, it has a lot of other, like for example, hypertension, hypercholesterolemia. That's the trend. That's where it's going. And then for this one, as you can see here, if you start from conduct disorder, you get ADHD. From there, you have linked to asthma. So the way that different reported ancestries have different manifestations of this disease trajectory. So we were able to kind of bring that type of visibility to these diseases and their trajectories. And then what we can do now is that we know that not all patients are the same. If somebody is from a European ancestry background, so the way that we need to treat them compared to Hispanic, Latino, or African Americans should be different. Because the way that the diseases trajectories are being formed from our data-driven analysis is like different. So then we can now personalize things based on that. So that's what we can do here. So that's one example. We were building disease trajectories. Now, again, just like we have disease data, this electronic health record also have prescription data. And then prescription data is like what medication somebody is taking. So we can collect all of that and make what we call as a prescriptome and apply the same technique. To take the drugs instead of the disease, you build this, chains or networks of drugs that's prescribed. And then you ask the same question, how it differs across, different ancestry, what's happening. So we saw that, different ancestry groups are using different types of medication. And then we also saw that, we also looked at that data, and then we looked at it in a way that, what's happening with therapeutic switching. Like, patients sometimes switch medication. If you remember the original example we talked about where blood pressure medication has been switching, that's a trend across different types of medication classes. So this is one part where patient was switching from fast acting to long acting insulin, or vice versa. So we see that in this one. And what happens with that is another thing that we learned from this data is a lot of times patients are taking too many pills. So there is a concept of polypharmacy. And then what we saw that, if a patient is taking too much of medication, that could sometimes lead to secondary side effects and poor outcome. So what happens is that, we looked into the data, we saw, a polypharmacy, which is a concept of more than 4 simultaneous drugs prescription. And they again, change according to different, ancestries. And then also in an age-dependent manner, it kind of changes from 4% to 62% of the population, which is just kind of an insight we cannot get if we don't apply these type of algorithms and methods to this data. So I'll let you kind of think about that for a minute. Now let's switch gears to computational diagnosis. So what's computational diagnosis? One of the main challenge in medicine is that, if you can think of, what could be the reasons patients die, now that we are in a different world with Corona, and then, let's say, take a moment, maybe like last year, same time, what could have been the most leading cause of death in the United States? Do you have any guess? Do you want to give any comment on that? So we can say cancer, heart disease, and this could be like one or the other, could be one term. But do you know what's number 3? I'll tell you. It's called medical misdiagnosis, medical error. And this was a BMJ article that published in 2016 that showed that in 2013, this was 3rd leading cause of death. And then what is misdiagnosis here? So it could be error in diagnosis, improper performance, failure to supervise or monitor the case, could be even medication error. So this is a huge problem. And then how data and machine intelligence can help with that. So if you look at, let's go back to cardiology example. If you look at one modality in cardiac for diagnosis, it's called echocardiography. Some of you might have got it as part of your annual checkup. And then what you do with that is you basically use a device. You use the sound waves to detect the size and the shape and the behavior of how things are within your body. And then what happens if you take just echocardiography alone? There are 7.7 million patients, and then there are around 100 MB per data, and almost 700 TB data that's compressed, and then that's being generated for what we call as a Medicare patients. Medicare patients are the patients that's covered by the government, using health insurance. And then if you convert that, uncompressed data, that itself is petabytes of data. So you just think about the staggering scope of the work and the data that we have to do. And what happens is that American Society of Echocardiography recommends trans echocardiography examination for general evaluation of cardiac structure and function in the setting of 200 diseases. There are 200 diseases that a cardiologist and echocardiography specialist should memorize before if he gets into the practice. So do you think someone can do that? Is there room for error? I'll leave that up to you. And then let's look at one of the challenge here. So let's look at one difficult disease to diagnose. Let's say diastolic dysfunction. So what happens with diastolic dysfunction? There are 3 million cases. Patients have early diagnosis. Patients could get better. But the problem is that this is the box there, the blue box with all of that is what somebody need to kind of think. You get that picture like that, the black and white picture. You can do some coloring and all. But then in the end, a physician or a ecotech need to go through all of this data and then come up with a class normal function with athletes had grade 1, grade 2, grade 3, like that. So is that cognitively possible or cognitively taxing the situation? So can an algorithm learn this and perform this classification task? The answer is yes. We trained a machine to basically look into a lot of these type of data set. We built a model. We built an ensemble model by integrating 3 different types of machine learning. We were able to predict that with an accuracy of around 87%. Not of course, not 100%, but it was one of the best in the industry at that time. Again, this was published in 2017. And we have applied the same technique to a variety of other diseases. We have applied this to hypertrophic cardiomyopathy and athlete's heart. You might have seen that patients who are very athlete, they are getting heart issues. The issue is that when the clinical manifestations of an athlete's heart and hypertrophic cardiomyopathy, they are almost similar. Hypertrophic cardiomyopathy is the thickening of your heart wall. So then how do you differentiate between the two? So we designed a machine learning algorithm for that. And again, this is the workflow you use. You can definitely refer to them. We'll definitely share the slides with you. And then we also collaborate a lot, because these are complex problems. We cannot apply our own algorithms all the time, right? So we collaborated with a company. Back then they were not acquired by Intel, but now they're part of Intel now. So we used a particular type of algorithm called cognitive machine learning approach, cognitive learning approach. And then we applied cognitive learning approach again to develop a different classifier for something called constructive pericarditis and restrictive cardiomyopathy, and as well as controls. Again, a difficult disease to understand using this type of traditional approach. So you've seen that as an example. Now we're coming to the last example. Okay, and one of my favorite too. I spent a lot of significant part of my career in in solving this type of problem. So we might have heard about drug development is a costly endeavor. It's true. It takes a lot of time, a lot of effort to kind of develop a drug. But with COVID, things are changing. We are accelerating. We have new vaccine modalities now, and then we have new way to do this. So COVID has changed a lot, and especially within our field, it has changed a lot of things. But just before this, it was like this. It takes almost 10 years and 800 million, north of 800 million to develop something like that. Then what happens is that if you have a drug, that drug could sometimes have an effect on a different disease. You might have heard this often. There are different examples like that, like a rheumatoid arthritis drug could be applied for renal transplantation. For example, as patients with urinary tract infection, cycloserine could be potentially applicable to tuberculosis. Like colchicine is a gout drug, but we also use for Mediterranean fever, and then also like pericarditis, for example. So there are a lot of different examples like that. So what we did was we kind of compiled all of this data using a variety of approaches, both machine learning approaches as well, and then compiled this and developed a resource. You can go online and see that. And then what's really happening is repositioning is a way to kind of find use for an existing drug. And there are different concepts around using a drug in a different way in the pharmaceutical world. And then there are concept of changing the dose, changing the drug combination, reformulation. But what we are talking about is really reposition, use an existing drug. And what you can see in this network figure is that different examples of cancer drug used for other types of cancer. Different cancer drug has been used in other categories of disease, like whether it's infectious, endocrine, respiratory. So a lot of different diseases are available. And what why this is important, you can definitely save time. You can definitely save, the cost as well. These are all possible. And above all, we've identified that, repositioning works because of the biology. Because, even though we don't understand the entire finiteness of biology, there are elements of biology that, for example, a gene can function in different way. There is a concept called pleiotropy. Pleiotropy means nothing but, one gene influence two or more different phenotype. Maybe the same gene have a role in cancer. The same gene could have a role in something like, cardiology, for example. So there are two different diseases, right? But then the gene could have influence on both. So now what we did was we used this concept and come up with a strategy to identify an alternate drug for something called statin. Statin is one of the world's most prescribed drug, and it's $1 trillion drug. And then, but what happens is that 62% of the patients have, some kind of side effect. People are stopped using statin. But the question that we have used was, can we find something like statin, which is not statin, means a different class of drug, but it can do the same thing. Basically, it can reduce the cholesterol level, but using a non-statin molecule. So we use this approach called sort of molecular matchmaking using machine intelligence. And using that data, we did some data mining in electronic health record data. And then what we did was we were able to find a drug that's prescribed independently and also with statin. And we found almost 1,000 patients with drug and statin. And what we found was, this drug can reduce cholesterol as good or sometimes even better than statin. So a typical drug discovery would cost $800 million. We were, and then preclinical alone would cost $200 million. And then we were, running this using the computing time and analytics under roughly, $10,000. So this is the kind of things you can discover. This is still going through validation and then also peer review with some major journal. And then we have also applied this to this concept of machine learning to repositioning. And then we now have, if you have a small molecule, we can look into different patterns within the small molecule and it can tell you whether this will be a compound that can work for different diseases. So we've developed that type of algorithms as well. So we have seen what is AI in healthcare. We have seen different type of data. We have seen tools and methods. We have seen some databases and a few of my interesting use cases that I'm really happy to share with. But now I want each and every one of you to take this back to your universities and colleges and encourage your students to work on it. And to enable that, I want to share something called a framework that we have developed. So there are other types of framework too. This is not the only one that's out there, but this is very close to applying AI in healthcare. So it's nothing but a set of guidelines how you can do a project like this. So we can talk about this in a little bit detail, and then if any of you have questions, we can come back to this as well. So basically, this is geared more towards cardiology, imaging studies in cardiology, but it can apply any type of healthcare and AI projects. So here we go. So we call it Prime. And here is an example of an end-to-end ML pipeline. So first of all, the first step is to define the project. What is the goal of the project? Is it identifying which patient is at risk, or is it identifying how patient is going to behave? You have to define that. You acquire the data. You know how to acquire them. You can go to talk to your hospital, local friends in the hospitals or the university hospital. And then you need to prepare. I showed you the data is not clean. You need to apply a lot of standards, a lot of ontology. You need to do that data cleaning and preparation. Once you have that data, you have to use some data description and visualization. And for that also, I showed EHDVIS is one example. But like that, you can apply your own, any exploratory data analysis tool for that. And then once you have that, you need to sometimes, once you have the data available, you need to split the data, training, testing, validation, cross-validation, a combination of this or all of that. Then you need to do, feature selection or feature engineering. You need to select algorithms. We have seen how we are applying different algorithms. And then if you come to this side, you have to do model tuning. You have to generalize it, do some testing and evaluation. Maybe you apply ROC or AUC, F1 score, mean absolute error. Bright score, doesn't matter what depending on your problem that you're doing, you can do that. And that consists of your step 4. You do the training and then the testing as well. So once you have that available, what you do, so you have the data part, you have the modeling part, and then now you need to report this, and then you take this to either you're working with your friends from the cardiology side, from the public health, or from infectious disease. You interpret and report that. Sometimes you need to develop a web app for that. Maybe sometimes you need a health app or digital health app, and then you need to test how reproducible this is, because another challenge, it may work for this hospital, but not from the data from another district or another state, maybe not in a nationwide. So you need to you revise and optimize your model a lot of times. We spend a lot of time in doing that, because all of this initial part is really fun, but then how do you transport this to other centers and making sure that they're working there? The productionization of AI and ML solutions are a significant part of that. And so you need to ensure reproducibility. And once you have that, and then we can talk about the limitations and what other alternatives you can. So this is in a way you can design and run an end-to-end an ML pipeline for healthcare problems, and it could be applied to others as well. And then about feature selection, we've seen feature selection is an important part. You can handcraft your features, like using certain methods, or you can do if your feature is data is too sparse, too complex, you can do dimensionality reduction. Sometimes you can just use deep convolutional or encoder. So there are different ways you can either engineer or you can learn it from the data itself. For example, deep learning does that. They learn the features from the data. And then model assessment, we have different approach here. You can do a more simple 5-fold, K-fold cross validation, or you can use Monte Carlo class validation, or even use bootstrapping as well. And last but not the least, so you have 2 examples here. One is for a supervised, and then another one is for a non-supervised. I'm sure you've seen this enough examples today. You can see that we talked about that. So now let's talk about a bit of a best practice strategy. You need to make sure that what's designing the study plan is important. The data standardization, that we have seen a lot of that. Selecting ML models, we've seen that we have applied a variety of model assessment, evaluation, replicability, and then the final reporting limitations. So you will have all this material available, or you can even go and find this in the JAC website as well. Okay, we are coming to an end of our session, or at least my talking part, and now we'll have some time for interaction, I'm sure. So what's the future direction here? So data availability is growing in biomedicine and healthcare. I'm sure you all know this now. And evolving platforms including EMR, integration engine, data mining systems, and phenotyping approaches are becoming far more normal now. And we now have affordable sensors. If you're not into anything to do with software, I would encourage you all to think about developing sensors. That's going to be the next big thing. Like, we all need, a smartwatch that can measure our different, biological or physiological parameters, and integrating scalable and low-cost molecular profiling, and there is genetic testing, genomics, and bringing that to the doctor's office. That would accelerate, again, application of AI in medicine. We need to do a lot of standardization, and advances in AI, including, AGI, will further improve the application of AI in medicine. So that's where I wanted to kind of come to the conclusion. But before we leave, in the Indian context, this has even huge scope, actually. We need to build this now. We are in an inflection point in India now. There is going to be national policy around health insurance. We are all going to move to electronic health data sets. There are a lot of opportunity that's going to coming in, like whether it's text mining in NLP of index scripts, notes captured in paper records, a lot of discovery potential, effective therapies, and do a lot of collaboration. If you don't have a clinical background, go collaborate with somebody from your medical school, somebody from your biomedical engineering, somebody from the other department, electrical, electronics. Do build that undergraduate research portfolio, like undergraduate masters or transdisciplinary. So I can even tell you a very interesting thing that I just learned end of last year. One of my friend is an associate professor at Texas A&M. They have something called an NMed degree. They are teaching students both engineering and medicine. So they will become sort of a crossbreed students coming out. And then there are a lot of, in the United States, MD, PhD programs are very, very common. Like somebody will get to do a medical degree. Along with that, they can do a PhD in, I don't know, systems biology, computational biology, software engineering, you name it. So we also need, and each and every one of you could play a role in that, like to build these type of unique programs as part of your university. And if you need any help, reach out to me. I'm happy to help as well. And any of you looking for collaborations, if anything that's you've heard or anything around this subject, let me know. If I'm not working on it, I'll be happy to connect you with the right individuals that work in this area. I want to thank my colleagues and collaborators, and especially and two of my mentors, Dr. Sen Gupta and Dr. Joel Dudley, and then Ben and Kip. Kip was an MD PhD student at Mount Sinai. A lot of the work that we talked today, and then again, Benjamin is now an assistant professor in New York. A lot of this work that we have seen is funded by NIH, so that's in a way powered by American public, but then all of this data is available in the public domain. It's available to you, to me, to everybody as well. And before we end the session, I want to kind of, I run a small mentor network. I take a few select set of students and kind of give them some mentoring in data science. And this is the students that I mentored in the last fall. Some of them are still with me. And one of the students actually started a startup. So I'm going to ask each and every one of you to help me with something. He's looking for students, very good students interested in this type of interdisciplinary area. And the startup is based out of Kerala. And then they are in the mission to build a portable miniaturized smart kidney. The company's name is Molecular Robotics. If any of your students are interested, please let them reach out to Shamsuddin Marakar. He's from KISAT. He's an electronic engineer plus an AI in MTech as well. So it's a great team. And then, if anybody's interested, please let them know. And I want to thank you, and of course, for the organizers. And then you can reach out to me via my email, or you can tweet to me. And now let's open this up for questions. Thank you.
Now it's a Q&A session. So those have queries, you may please unmute yourself and you are free to ask. So we have some queries in the chat now.
Okay.
So please tell the basic difference between machine learning and AI.
Okay, so the way that I would define the difference is that AI is a sort of I do have a slide around here. Artificial intelligence involves a variety of techniques. So let's put it that way. And then, yeah, let's go here. So as you can see here, artificial intelligence can do a lot of things, like, whether it's robotics, it could be computer vision, it could be text mining, it could be NLP, it could be, you name it. That's a broad approach where we are teaching machines to do things in a more intelligent way. So that's artificial intelligence. Within that artificial intelligence, one subfield or sort of a sub-vertical is what we call as machine learning. And then machine learning is, in a way, if you ask, it's a bit debated topic, but then I would say it's an extension of statistics. So, for example, statistical models, you definitely need a lot more assumptions. Whereas, once you kind of cross that into machine learning, you have a set of approaches, set of methods that can do, for example, a data-driven analysis. For example, you do hypothesis-driven in statistics, but you come here, you can do analysis in a more data-driven way. One example would be, you can run linear regression on your model, using 10 or 20 or 30 variables. But what if you have a model with 100 variables or 1,000 variables or 10,000 variables? So that's where you kind of pick up something called a random forest or other type of method to solve that problem. So the way that I perceive, and then people will have different opinion on this, but this is my take. So we'll start with the field, if you take the field of AI, it's a subdomain within that. So that's what machine learning is.
May I please? Am I audible?
Yeah.
Yeah. Good morning, everyone. This is Subhadra. I'm calling from Vizag, Geetam University. Sir, I have a question. Can you please distinguish between machine learning algorithms and deep learning algorithms, where actually we apply deep learning algorithms? Both of them, they are, as you have quoted just now, both of them are the subset of AI. All the algorithms and the applications we use will be coming under that. But can you be more specific where we can use deep learning algorithms?
Okay, so let's take an example here. Let's take one of the example we talked about. I have a picture of a flower. I don't know what this flower is doing, right? Now, what flower is this? So for that example, I can create a machine learning algorithm for that example, or I can do a deep learning algorithm too. So if I need to create a machine learning algorithm, what happens is that I need to define what the features should be. Okay, so I need to say that, okay, for this flower, the color is red. Color is one thing, and then the number of petals is another one. The way that the green content within the picture should be this. Like that, I need to handpick and hand code hundreds or thousands of features for that task. But if I use a computer vision algorithm from that use deep learning approach, what happens is that I let the computer or the neural network architecture to pick the features. So the feature selection part will be done by your algorithm as well. So, typically if you go by, machine learning, you either do supervised or unsupervised, but you are the one still defining your feature in a machine learning algorithm. Whereas when you come to a deep learning algorithm, the machine will define it for you. So that saves a lot of time and energy for you. And I can tell you, when I was, again, a grad student, like we used to look into a particular experimental technique called RNAi. So basically we block certain RNAs in cell and takes the images. And then I still remember hand coding a lot of imaging features, like the RBG content, and then what's the grayscale of this, how many, sort of hotspots within the figure. We were hard coding all of that 15 years ago. But then now you can easily do that. We took months to develop a classifier back then, but now you can just in a half a day you can create that, these type of solutions. So one fundamental difference. There are other differences too, that you don't have to hand engineer the features. Algorithms can do it for you.
Does the selection of algorithms depend on the data size or the application which we are going to deal?
Yeah, so definitely for deep learning, you need tens of thousands of images. Yes, so that's true. But machine learning, you can do with even smaller subset of data, hundreds of samples or thousands of samples. You can make a decent machine learning model. And the rule of thumb in machine learning is that always more data the merrier. That's definitely the rule of thumb. But you can definitely run machine learning models even with much smaller data compared to deep learning.
And one more. Sorry, am I taking more time? I just have in last night I gone through an algorithm as YOLO, YOLO. Can you be more deeper into where YOLO can be exactly used?
Can you explain is this yet another online learning algorithm? What is the YOLO?
YOLO algorithm, I have come through one of the blog from Facebook. So where I have a block of data science. So where I have come across this YOLO algorithm which would be applied in deep learning. So I was a bit confused, like what exactly is, because I didn't go through any of the textbooks or any of the material of YOLO. So I just wanted if that you could help me in that.
Yeah, so sure. Like I said, almost every tech companies are coming up with the new methods and technologies these days. So I've heard of a version of, it could be one of the online algorithms, but I've not come across this specific one. But like for example, but we do use a lot of solutions from, let's say, Google and Facebook. And one thing I can tell you is that they have very good text mining algorithms. Like we do use them in our clinical text mining approaches as well. So that's one area where we use Facebook's algorithms. And then one good thing about a lot of these technology companies is that they're open sourcing a lot of these algorithms. And I'm sure I'll definitely need to look into that. But thank you, though. Yeah.
Thank you.
So we have one more question. I'm doing research in insomnia. Could you please suggest where to find the recent data set?
Uh, Great. That's nice that you're working on insomnia, and you should definitely reach out to folks at NIMHANS, and I can also connect you with a few of my friends who are either trained at NIMHANS or working at NIMHANS now. You could find some data on, for example, there is a National Institute of Mental Health in the United States. They do have certain databases. So if you send me a note, I can definitely provide some links on that. There are some data that includes EEG data, sleep data. These are the type of data that's available in the public domain.
Sir, can you provide an insight like on the data collection aspect? Because I think that's the main constraint where we can get everything about a human being being stored at a global level, which can help like utilize it for various models, right? Not only medical, but finance, etc. So is there any work going on in that space?
That sounds really good one. And then, very sort of a transformative idea. You should definitely think about that, in a little bit more detail. So the problem is that, not everybody wants that to be linked, right? Like, I do not want my healthcare data linked with, my credit card or my financial data for that matter. But, we often, we have often hear about this, that, your zip code, or your PIN code, where you live, kind of defines your health in one way or the other. Like, whether you're, living in this side of the road or that side of the road, where, it all depends on, in a way, contribute to your health. So, and then also we say that more than your medical health record, if you get access to your credit card spending, sometimes we can define, how a patient is going to do over the next 5 years or 10 years, things like that. So it's a good idea, but then it has a lot of privacy concerns, and then patient privacy is extremely important. And if you ask me, I do not want my health data to be integrated with the rest of my own personal data. But I do, as somebody who believe in clinical trials and also the power of this data, I do donate my data for research as well. So I do participate in research studies too. I do contribute my data, but not with the rest of the other type of data. But it's a great thinking. We might see that type of evolution in this field. So sort of a global database in the collect, not just this one, but not just the particular health data, but other types of data too. So yeah, so that's a great idea.
Hello.
Yeah.
Yeah, sir, I'm doing PhD in nutrition monitoring for geriatric patients.
Excellent.
Yeah, so I'm using invasive methods, sorry, non-invasive methods. Fine. So actually, I want to monitor the geriatric patients' nutrients rather. I can say, matlab, the carbohydrates, fats, and all those things. So can I go with AI or should I go with machine learning only for prediction? Is there any
So,
is there any need to go for AI or not? That's what my basic question.
so yeah, you have to think about AI like it's a tool, right? It's a
Yeah.
tool, and you have to think about it like it's a garden, right? Like so it's a garden of tools. Like you in a garden, you have your peonies, your roses, your bougainvillea. It's like not every flower will be appropriate for the kind of use that you're thinking of. So if you want to kind
That's
of
true.
make a symbol in a single flower bouquet, you just pluck your roses out of that. So it's like that. So it really depends on what the problem you're solving, what's the type of data that you have, what is your end use, and depending on that, you can use these techniques. And then I can tell you, in a way, we don't go to a problem thinking that okay, I'm going to apply AI to this problem. But the problem is complex enough. You cannot use the standard statistical approach. You then will automatically hit the big data. You automatically have to bring in these AI algorithms because these AI algorithms are not error free. They are very, very error prone. If you have a smaller set of data, maybe you just need a statistical model. You don't need advanced AI or anything. And then but then as you're doing a graduate school now, it's your opportunity because you are now living in what we call as AI spring period. And if you're writing a thesis, please see if you can apply one of these, any of these algorithms for that matter. I would highly encourage you to discuss that with your thesis advisor. Yeah.
Yeah. Thank you, sir. Thank you.
So thank you, sir. That was a wonderful, interesting, and informative session, opening to us the world of AI in health. So we are really grateful for the time and effort you have taken, and you shared your thoughts and learnings, experience in healthcare. So thank you so much.
Oh, thank you. Thanks everyone. Thank you for the time. Appreciate that.
Okay. So participants, now we'll have a short break, and please be back at 11:45 for the next session. We have put the link of feedback also. Please fill that too. Okay. Thank you, sir. Thank you.
Thank you. Take care. Enjoy your sessions, everybody. Bye. Take care. Bye.
അത് കഴിഞ്ഞു ഇനി ബ്രേക്കാ ഒരു ബ്രേക്ക് ഇനി 11:45. ഇപ്പൊ ബ്രേക്ക് ആണേ. ഇപ്പൊ ബ്രേക്ക് Preeta Miss?
Yes, yes. Lija Miss, are you here?
Our guest resource person have joined. We'll start in 1 minute.
Sure, ma'am. Thank you.
Good morning, ma'am. This is Shaila.
Good morning, sir.
Good morning. I think I cannot share my screen. If you could enable that, so probably I can share my screen after your deck.
Yes, sir. Yes, sir.
Preeta ma'am, I think we
Yes.
can start now.
Yeah,
Okay.
I can. Yeah, I can have the access now. Okay, I have.
Okay, sir. So once again, warm wishes to all the participants. Back to this FTP program. This is our second session. The session title is AI for Social Good and Use Cases. This session is handled by Mr. Tarikamla Shailakumar. Mr. Shaila is a data science leader with 20 years of industry experience. Currently, he is heading AI ML initiatives at Larsen and Toubro, Smart World and Communication Business. Prior to L&T, he was associated with Government of Andhra Pradesh, HSBC, Wells Fargo, and played various leadership roles. Mr. Shaila has received numerous certifications from PMI, IBM, and Sun. He is a BTech degree holder from University of Madras. He received an MBA from Symbiosis, Indian School of Business. Currently, he is pursuing PhD in AI and finance field. We are very happy to have you here in this FDP program, sir. Waiting for your knowledge sharing. Over to you, Shaila, sir.
Okay. Thanks a lot, ma'am, for a very brief introduction about me. So at least I will not introduce myself again. It will waste a lot of time for others. And first of all, I would like to thank the institute having me here in this occasion. I know that I can see a lot of intellectuals in this forum, and I'm not here to give any lecture to you, definitely, but I'm going to share what we are doing in the space of social good related to artificial intelligence based on my experience with the last 2 or 3 organizations. Okay, so that is the context of this. And this is also not a technical session, to be frank, but I will touch base some technology related aspects as well. I heard from Mr. Jacob that the participants are actually from various faculty, staff, as well as the scholars who is actually doing a lot of research in this particular space. So that's the reason I would like to touch base a little bit of technical aspects, and at the same time, the challenges this industry is facing, particularly with respect to data or bandwidth, etc. So that also I will touch base, so that whenever you are doing any research in this particular space, probably you can keep those things in mind, and then probably address those things well before your thesis or your research. So with this, I would like to share my screen. So please ask me any questions in the chat window. Probably for every 15-30 minutes, probably I will check it, so that I'll let it be a little interactive session rather than I keep talking. Okay. Okay, so let's start. So the agenda will be something like that. So what are these social good use cases or social good areas where we're supposed to focus, and then what is our Indian national strategy for AI around this particular area, and some use cases, what probably industry is expecting or the society is expecting, and at the same time what we are doing, okay, from the from our organization L&T, and the various challenges in this particular area where it is very, people think that artificial intelligence will solve every problem, but unfortunately we have a lot of challenges as well, quality of data, or the computing requirements, or the 4G 5G network bandwidth. Still there are problems around it. And then I will give some basic technical AI framework, and then probably what industry is expecting from a data scientist. I don't know whether any of you probably trying to pursue the corporate roles in the future, so probably that will be helpful. Okay, so setting the context, I think I already covered a little bit about it. So it is a bringing awareness of the areas where AI can bring value in changing the world, global guidelines for social good, and the Indian context and focus areas for India, and the AI opportunities in this particular space, and what we are doing in this particular area. And as I told you, it's not in a technical session, so you can always be in touch with me offline if you need any help, from the data point of view or from any guidance point of view. So we will definitely, try to help you guys out. Okay, so let's start from the United Nations, initiative, which is called Sustainable Development Goals. We call that as an SDG, because majority of us might have facing some problem. Okay, what is social good? Where I should start? If I start something that is really useful to this society. Okay, so United Nations actually drafted 17 areas where they want every country to put some focus, so that we will achieve year on year improvements in those areas. So I will talk about those 17 areas, but if at all you are interested to go more details about those areas, so this is the link. So this is a United Nations link, so you can understand those 17 areas and also the details of those 17 areas in very detail. Okay, like what are their targets for next 1 year, 5 years, or 10 years, etc. Okay, so these are the 17 goals they designed with due consultation from various countries or economies in this planet. So one is no poverty. Okay, because poverty is one of the problems. So how we supposed to address this poverty, probably by leveraging some technology. Okay, and zero hunger is these are all goals for the United Nations. So they don't want any poverty, and they don't want any people suffering with basic food, basic needs, right? A good health and well-being. So I think you might have seen during the COVID-19 situation, even so-called developed the superpower of this planet, like United States of America, so they suffered a lot. Okay, because the number of beds are not sufficient, or probably the number of medical staff not sufficient, or number of medical equipments not sufficient to meet any such sorts of pandemics if they encounter. Because COVID-19 may not happen every time, but country like US unable to handle the situation. So we can understand other countries like India and China. I'm not saying that India is a poor country or China is a poor country, but obviously, the infrastructure what we have and the type of demographics, what we have, and the population what we have is much more difficult, because in India probably we have more 3 to 4 times more population than US, and then China is more or less the same thing, right? So then, whether we are giving a quality health to all the people of our country, so that is also a challenge, and that is also a goal from UN. And then quality education, I think no need to tell you anything, because particularly our in India, the government schools, the equipments or the ecosystem of our government schools are still not up to the mark compared to probably the other standards of the West. Though there are many governments coming to the power, and then they're trying to do a lot of new schemes in these areas, but we have our own problems. Either it could be corruption, or it could be the focus all the way from head of the state to the last employee of the state. So the same passion, and then the interest has to be there to make these things change. And then gender equality, we keep talking about the females are equally important and equally good when it comes to any intellectual or probably working or probably the way they handle things. But unfortunately, in many of the areas, including India, is still, I'm sorry to say that, but it's still a male domination uh, societies. Okay. So that has to be removed slowly with women empowerment. And clear water and sanitation, I think all these things are quite evident for all of us. I need not explain you what type of problems we are facing. Well, in the context of India, probably in the context of US or UK, or probably some advanced countries like Norway and Germany and all. But countries like India, we are still having these problems. Affordable and clean energy, I think there is a very good initiatives coming from the current government, both central government particularly. They are encouraging renewable energy, so that there is a less reliance on conventional fuels like coal or diesel or petrol type of thing. And decent work and economic growth, so that is a generic statement, the per capita income of individuals, etc. And industry innovation infrastructure, uh, though India is doing very good when it comes to the services industry, but we are still short of the manufacturing ecosystem. So Make in India, from the current government, making some progress definitely, like where we are getting a lot of mobile companies, they started their business here. Other automobile companies are starting from India. Probably the medical fields, where we are doing much better probably compared to others, but still our manufacturing ecosystem, our logistic ecosystem is still not so great, because the road network is good between two good cities, but these organizations or the manufacturing units will be in some, most of the times it will be some in remote areas. So how they are connecting to this infrastructure is still a challenge. uh, so inequalities, like it is more of caste, religion, and poor, rich, and all, so that we have to reduce, so that everybody have a equal voice across the country. And sustainable cities and communities, I think this is not the topic for anyway today, but in one of the session I was talking about this particular area where today, if you see, uh, close to 45 to 50% of the world's population are in cities. Okay, so let's take any of your cities in your area, or probably I can always take my city in Hyderabad. So Hyderabad city built probably 400 years or 500 years, if I'm not wrong, and the population that time probably a few lakhs or few thousands. Now it is almost a crore. So the same infrastructure, supposed to cater to the increased population, either it is related to the roads, or whether it is related to the energy, or whether it is related to sanitation, or related to healthcare, or related to energy or power, something like that, traffic, etc. So our city is supposed to be sustainable, uh, you know with the growing population, particularly in cities. So we are expecting that more than 60% of the population will be living in cities, probably in the next 5 to 10 years of time. Okay, with one flyover probably may not solve the problem, right? And if at all we want to expand a road in the core area of the city, so there are a lot of legal implications. We need to demolish some of the existing old buildings. So there is a huge legal issues around any development activity in India. So those are the things we need to handle. Otherwise our cities may not be sustainable, because if you see the China, they're building the cities itself, someplace, and then they're trying to encourage people to migrate to those new cities, and then they will be having some employment around those cities with some industries, etc. So that is what probably even we have to do it. Like for example, in Andhra Pradesh, there was a new capital proposed, and then work is going on, but of course now it is into some political conflict. But those are the initiatives probably we need to encourage, and then see new cities supposed to develop, so that people will be spread across these new cities, so that there is a less stress and pressure on the existing cities. Like China is a very classic example. They will build cities like in Gulf, they will build new cities altogether. But of course it involves a lot of money, but they are the future for our economy. And responsible consumption and production uh, of anything, because we should not waste things. Okay, and at the same time we cannot produce too much. If you produce too much relative to your demand, then obviously there's a cost involved. On top of it, the moment you are producing more things what is required, probably you are producing more carbon. Okay, more CO2, more CO2. So that is also not good for us. Okay, so that's where we need to balance it out. What is required by maintaining the price, as well as our environment. Climate action. So I think we're all aware of that. There's too many places where or particularly in India, China type of growing economies, we have too much of pollution, and that leads to a lot of side effects. So we may not be even aware of that, because that pollution will pollute your water, your air, and then people are taking that water, the people are breathing that air. So that leads to a lot of health issues, and their life expectancy, and then their thought process, their intellectual capabilities may also go down. So there are a lot of side effects. And then life below water. So probably I may not be talking much about it, because I don't know much about this, but this is all about balancing, like the coral reefs, etc. in Australia. As people are going for more fishing, so they are also sort of disturbing the ecosystem of the water. So that is also has a side effects. I'm not the right person probably to talk much about it, but that is what our researchers were talking about. And life on land, this is also the ecosystem, not only human beings. So we need to make sure that other animals and birds are supposed to live along with us, because it's more of a deforestation, what we are doing as we are urbanizing a lot. So that's where we need to handle as well. And peace and sorry, this peace probably wrong, but the peace and justice, and then strong institutions. So this is all about a framework around our judicial system, and then partnerships for the goals. So like for example, India as a country may not be doing having the capability to do everything, right? So we need to partner with either institutions, or probably other countries to meet these United Nations guidelines. So this is a high level view of what is UN's goals set for all the countries who are part of the United Nations General Assembly, or whatever you call. Okay, so this will give you some sort of ideas. Okay, these are the areas where we can add value. Okay, either it is through technology or through coming up with some way of improving these things. Okay, I don't think so we have to do every problem the technology can solve it. It's not about that. Individuals has to respect something, because technology will help you to give the guidelines how to drive on highways or probably on city roads, but that is up to the individuals who supposed to follow it. Okay, and then police may penalize you if you are crossing red light, but penalization probably a one way to get the money to the government, but at the end of the day you and me supposed to be responsive or responsible citizens, so that we all can change or probably contribute in achieving these goals. Okay, so that is a UN story. So then what is the India story? Okay, so no country probably can take all these 17 and then try to address all these 17s parallelly, because it involves a lot of policy changes, or it involves a lot of money to be invested, because overnight I cannot bring the innovation to this country, right? Because innovation has to start from the school, and then institutions like you to encourage the students to do a lot of innovation. Okay, because it's a long process. Okay, and probably the road network or logistics, it will not happen overnight, right? It requires a huge investments. On in spite of the huge investments, it takes some time. Probably it takes few years to build that ecosystem. Okay, and water sanitation, I cannot change my city overnight with a great sanitation mechanism. It requires a lot of time, money, and people's, right? So that's why India took 5 initiatives to leverage particularly technology in those 5 initiatives, so that they want to achieve these goals. So Niti Aayog is the one who design and to plan for these things, and then they spread this across various states, right? Because I think we are all aware of the Niti Aayog. Earlier we had you know planning commission, so now it is Niti Aayog. Okay, I will talk about some of the algorithms, Bharat. Don't worry. Okay, so I have one slide to give some synopsis of various algorithms and classifications. Okay. Okay. So going back to our topic, so our focus areas. So healthcare is our focus area. If you go to Niti Aayog site, so I think yeah, so you'll go to this site, so you can find more details. Okay, because when I was with the government of Andhra Pradesh, so every discussion will start from UN, and then it will go to Niti Aayog, and then our use case discussion will start, because we try to connect what we are trying to do. Of course, that will solve any of department's problem quickly, but at the same time we need to link that to these initiatives, so that these governments also supposed to send their report to the central government, or probably central government supposed to share their initiatives to the UN, that okay, these are the things we are doing. Okay, so that way it will be very good from the country point of view to see, boss, we are doing all these initiatives to meet all the goals set by you guys for the benefit of this entire society. Okay, so increased access and affordability of quality healthcare, and agriculture, increased farmers' income. Farmers is the major problem in India, unfortunately. It is still 40 to 50% of people working in this particular space dependent on farming, but we are only getting a very small percentage of the GDP from 50% of the farmers. So there is a serious issue there, definitely. So our people may not be having that technology accessibility to see, what is the right seed to use or what's the right fertilizer to use. And then if some disease comes in, so generally they do a traditional way of, pesticides, etc. But, we have better ways of doing it. Now drone based cultivation is started, and then we have various sensors you can put on the soil and then see the soil moisture, and then based on that you can release the water. If you see majority of southern part of the India, we are still do a lot of paddy cultivation. So paddy requires a huge amount of water. Okay, huge amount of water. Okay, so probably 10 to 20 times more water is required compared to probably other crops like cotton or something, or mitch or something like that. They also give a lot of money. Okay, so we need to bring that awareness. So the institutions and then these research organizations in the area of agriculture, and then farmers, and then the governments, these are all things, are corporates, of course, so these all parties are supposed to come together and then do something. Otherwise, I think in Telugu or probably in Malayalam movies are probably also, there were a lot of movies around the farming and then the new way of agriculture, and our heroes overnight change the farmers mindset, and then they will do wonders. But that is unfortunately a movie, a 2 hours movie, but in reality we have a lot of challenges that we need to address. Education, COVID-19 great example, and probably your institution has that know-how and how to handle these things. But what about the primary schools or high schools owned by or managed by the governments, and they don't have the computers with the kids, right? And including teachers, probably they may not be having access to laptops or desktops. Okay, because you and me, we want to do a lot of research and we are earning money decent, so we buy various gadgets. But unfortunately, the poor kids, those who are going to government schools, they don't have any alternative except to go to school physically. So majority of the students probably lost one academic year just because of the COVID. So this is an eye opener for the governments, to see if something happens tomorrow. It may happen, who knows. Then we lose time like this. So I don't know how many students, I don't have those statistics in front of me. So those many kids into 1 year means is a huge loss, when you convert that into some monetary value. Okay, so we cannot even calculate those monetary loss. Okay, so then we're all aware that your institution probably having all online sessions or video sessions, that etc. And then now we have a lot of ed tech companies are there, they're doing like Byju's, and also they were very popular. Of course they will charge huge amounts. I was talking to Byju's consultant yesterday. My daughter written one exam, so she got some 20-25% of discount because she got some 96 and 97 percentile. So they were quoting me 1 lakh rupees to access to 8th class, 9th class, 10th class material. Okay, but unfortunately so few people cannot afford that much of money. But how we can give this access, a similar quality of knowledge to the poor kids, is what we need to think about. Okay, of course central government initiated many things. There is a huge library available over internet. You can download, I can view a lot of sessions from various government owned universities, right? So all those lectures are available. But again, at the end of the day, the villages still we have a problem with internet. And if at all internet is there, probably the bandwidth may not be sufficient. And if internet is there, bandwidth is there, probably our fellow kid may not be having a device to access this. Okay, so those are the problems facing in the education. And then smart cities and infrastructure, this is the area where we are working with L&T. Okay, on the agriculture, on the healthcare education, I worked with my previous organization. But in the smart cities and infrastructure, it's all about efficient and connectivity for ever-growing urban population. So I have some use cases around it where we are working, and a couple of demos I put, what we are doing it. So that will give you some idea what type of work is being under development or already deployed in various cities. And smart mobility and transportation, this is still a big problem in India. If you take like Hyderabad, okay, so metro we inaugurated probably a couple of years back, and metro is very nice, but metro cannot cover the 1 crore population, obviously, right? Because metro cannot go to each gully of our cities. So there will be some connection should happen between these metro points through some other means, either through public bus transportation, or probably Ola, Uber. They should have this having this type of connectivity, or probably there should be a good amount of parking available in those metro stations, so that instead of I take the car all the way from one corner of the city to another corner of the city, so I can park my car and then without facing any of my traffic problems, I can get onto metro, and then probably I can save a lot of time. And then another problem what we are facing, that if at all you want to go from one corner to another corner, okay, you and me, we are very acquainted with our own cities, is okay. But a foreigner is coming to see your city or my city, so we want to give him utmost comfort or information, so that his mobility should not be having any problem. So in majority of the cities, if you buy one ticket, okay, that too online, before you even coming from London or some other city, you can buy some ticket for a particular day. So with that ticket, you should you can use the same ticket for the bus, for the metro, or from MMTS, or probably you can use the same card even for Uber and Ola. Okay, so that level of integration is required to save time, and then to save a lot of these logistical issues. So that's what even we are working on, to have one card, because Hyderabad Metro owned by us, L&T. So we have that information, and then we are trying to integrate with these providers like Ola and Uber. So in one corner of the city, so if I have access there to the public transportation, so I should get an information in their mobile that what bus he's supposed to take, and that bus will come at what time. Okay, how much time it will take to the nearby metro station, and then from that metro station, so what metro train this guy supposed to catch, and then where he's supposed to get down, and then from there which bus he's supposed to take, and how much time it will take, and when it will come. There is any delays, we need to understand, and then he should also get a traffic congestion information. So is all about end-to-end integration of the mobility in a particular city. Okay, so this is all about that. So these are the 5 areas the Niti Aayog actually taken as a priorities. Of course, we all agree that these are the problems anyway. Okay, so unfortunately we have various challenges. The lack of broad-based expertise in research and application of AI. You may think that sir, AI is advanced, and then machine learning is advanced, so we can leverage it. But I'm going to bet everybody that when we want to do something in Hyderabad, I started a new team altogether for L&T. Before that, there is a pressure from the local police and the local municipality that okay, we need to deploy something quickly. So then what we did was we try to evaluate various foreign developers or products to see whether those products can be leveraged, of course with extra premium cost. I don't mind, because I want to meet the demands of my customer, right? So we analyzed so many of those tools I'm not exaggerating. 90% of those tools fail in Indian conditions. Okay, because say for example, face recognition, or probably the number plate recognition of a vehicle, or probably the crowd analysis, based on my surveillance cameras, right? So all these will work in probably US or UK because the camera quality may be better than us, or probably the environment cleanliness is much better than probably us, and the height and angle at which they put their cameras may be very different, so that they will get a much clear images than in India or Hyderabad. So obviously, the accuracies from those models, algorithms will not work here in India. Okay, so that's my personal experience. Okay, so and India also, people think that if I know few algorithms, I'm a data scientist. I will tell you what data science supposed to have in one of the slide. Okay, so that is what the expectation from the industry. Only model building is not going to sufficient. What I will do with the model, that model has to be deployed somewhere, that model has to learn either on his own or probably a periodic with a manual intervention. We need to keep training that model or retraining that model, a revalidation of that model. There should be some feedback mechanism. And then if at all I'm talking about 1 lakh cameras in Hyderabad, okay, none of the ecosystem will support that, right? If I go to cloud, I have to spend too much of money. If at all I want to keep it in a data center, I have to probably having thousands of CPUs to handle probably thousands of cameras. Sometimes that is also not will give any returns, right? So we have a lot of aspects we need to think about it. So that's where I'm talking about that level of expertise is still not great, not only in India across, but this is in India especially we're talking about. Absence of enabling data ecosystems, so access to intelligent data. So now various states now started their own open data framework, like so whatever data is available which is of public in nature, right? So that data they are trying to put it into a portal, so that researchers like you and me can access that data and then probably come out with various patterns, algorithms, or probably some outcomes which will be helpful for the city or for the government. But still it is at the nascent stage of the acquisition. High resource cost and low awareness and adoption of AI. So this is also a big problem in India, of course abroad as well. Do you think that a 2-year experienced guy, I am paying 30 lakhs per year? Okay, this is a reality. And then I have people like that. Okay, probably they are from some premier institutions and they have some good experience in what we are trying to do. But earlier when I started my career, 2 years experience means probably into 1 lakh. Okay, 2 lakhs. And I started probably 20 years back. Okay, this may not be relevant even today. If a 10-year-old 10 years experienced person, if he is getting 20 lakhs, I think it's a decent salary. And if he's getting 30 lakhs, probably he is a top 10 to 15% of the people who is getting that level of salary. But now the example what I given you is a 2-year guy, I'm paying 30 lakhs. Very expensive. If I'm not getting an outcome from this guy where I can sell that outcome and then I get the returns, then there is no viability of doing some use cases, because at the end of the day corporates will get money, supposed to get money, but at the same time I'm trying to also help the society in solving some of the problems, right? It's not a charity at the end of the day. So it's expensive. Okay, privacy and security, lack of formal regulations around data. So this is also a problem, because when we deployed mask detection, so BBC came to us, a BBC Telugu, a local version of BBC. So they took an interview from our IT cell head of Hyderabad police. So they asked 100 different questions around privacy and then about security, because we are capturing everybody faces. So there is always a problem from the privacy perspective. So how we supposed to do that? So those are the challenges. And also there is no regulations around the AI particularly. So there is no formal regulation around AI today. Okay, so there are still being worked upon by few nations in Europe. So probably that will come. But it's all about the ethical aspects of artificial intelligence and absence of collaborative approach to adapt. And this is what I was talking about. Institutions work independently and governments, they do their own stuff, and then people like us do our own stuff, and then probably the schools and colleges, they do their own stuff, and the actual beneficiaries like citizens, farmers, etc., they are doing their own stuff. So we have to have a collaborative integrated environment to really reap the benefits of any of the social good related artificial intelligence mechanisms. Okay, so quick time check. It is 12:25. Any questions? Okay, I think cool. Okay. So I will go very quickly because I just want to give some opportunities. Healthcare in India is a 200 billion industry with a 16% growth year-on-year basis. But unfortunately, these are the yellow things are the current stats, and then the opportunities are in green. So that we can understand where we can help. Like 0.76 doctors per thousand against 1 doctor per thousand. So still good decently, but still we are 25% shortage of doctors based on this particular statistics. Okay, so now we need to think that whether we really require a doctor for everything, because a cancer patient, probably a person under dialysis, probably they should go to the doctor. There is no other alternative. But a person is getting a small fever. Of course, I'm not talking about COVID-19 context, but in general, a small fever or cold or probably a tooth pain or probably headache. Do you really require to go to a doctor and then probably waste his time where he can use that time for a critical cases, right? That's what we did for Deloitte during my ISB, thesis. Okay, so can we put some virtual assistant in between, and then that virtual assistant will talk to patient intelligently, collect all the information, and then probably suggest a medicine temporarily if it can, because this guy not supposed to prescribe the medicines based on the various laws of the land today. Okay, but that is what we proposed. And let this virtual assistant is a chatbot, based on natural language processing based chatbot. So it will talk like a human being. So it keep on asking some questions either through voice or text, and then it keep on dynamically asking the follow-up questions like, if you say 1 or 2, I will ask, okay, since when? Okay, and then morning time, evening time, night time. So it's keep on intelligently will ask some questions and then collect the details, and then it feels that based on some algorithms or patterns, okay, I can propose some generic medicine, and then probably I can take an appointment for tomorrow or day after tomorrow based on doctor's availability. Okay, or if the patient is still facing the same problem, yes, so let's go to the doctor. Okay, so something like that. So these are some ideas, okay, where I'm trying to throw so that we'll think in those lines. So 2.09 nurses required, so we have 2.5. So here also we are close to 20% shortage, and 1.3 beds required for 100,000 people we have, but actually we require 3.5 beds, and 67% of the doctors for 30%, 34% of the urban population. So it is very clearly says that all doctors are in cities because they don't want to go to villages, because of course with their family reasons, economic reasons, financial reasons, etc., right? But only 33% of the doctors for 66% of the rural population, right? So these are the opportunities in early detection of diseases, disease diagnosis, and decision making and treatment, image processing, virtual assistant bots, ICU monitoring alerts. So these are some of the things, we can think about it. Okay, I'm going a little fast. This is some statistics only. There's nothing great about it. If you go to, as I said, the UN site or Niti Aayog site, so you will get a lot of these things. Okay, or probably if you Google it, you will get it. Okay, so agriculture, there's a huge potential in agriculture to do wonders, literally wonders. I was talking about farming data, decision making, and precision farming. Precision farming is that we suggested something. Let me take a minute to see what we can do. So in a village, say for example, so there are about 1,000 acres of land. Okay, so they are probably cultivating paddy. Okay, good. So I'm not talking about how they will cultivate paddy and all. I'm just talking about how with the technology we can correlate things. In the same village, there are about 5,000 animals are there, either sheep or probably goats or probably buffaloes, etc., cows, etc. Right? So then once after the paddy comes to harvesting, so there will be leftovers. Generally what we do that the leftovers will be fed to these animals. Okay, so now I can assess by some satellite images or probably through my drone, okay, what is the production and what will be the possible paddy outcome and what will be the possible the leftovers. Okay, that is called actually the food for the animals. So I will understand that, okay, so this much amount of food will come out of this after paddy, the removal of that actual paddy grains. So whether that amount is sufficient to feed my 5,000 animals in that village. If yes, okay, so you have a surplus, probably so there will be some surplus or a deficit. Okay, or if it is exactly balancing, that never happens, but is okay. So now I have the similar information of all the villages of a particular state, and I will get to all the details. Then if a particular village have a shortage of that food, then from where this guy is supposed to import from. Okay, so by reducing the transport cost, okay, at the same time I'm going to leverage the surplus which is anyway going to be not going to be used in that village. Can I take that to this particular village so that I can balance it out? Okay, that is one example we did for government of Andhra Pradesh. It was huge applause we received our team from various stakeholders, and then various state uh, the principal secretaries and secretaries came to us, and then we given them a session how we can do that. Okay, so there is a number of opportunities here. Say for example, if 10 acres of land a farmer is having, and then he is having a weeds, right? He has to remove that weeds from the field. And what this guy will do is, like, he don't know where these weeds are there in across the 10 acres land, right? So what he will do is he will put the pesticide for the entire 10 acres. But it is not required, first of all, from the cost point of view, from the environment point of view, or from the outcome point of view, and from the soil point of view. Because if you keep on putting the pesticides on the soil, then your soil quality will erode, right, over a period of time. So there are a lot of side effects. So temporarily you may be getting the good yield because you have money, you are spraying the pesticide, but you are actually spoiling the environment, right? So there is a precision agriculture where it will automatically detect where I supposed to spray. Only that much spray it will go and do it, and then it will come back. Okay, so this was experimented not in India, but it was experimented in many Western countries. So can we do that? Because even in India we are still struggling. In India, drones are not legal as of today. There is no regulations around it. Only for your marriage functions and all, they are using these drones. They are also illegal. Okay, so there is no legal framework in India to fly these drones. So all governments are actually working around it to see, to build some sort of framework around it. So then they will put, okay, you can go up to 200 meters, 300 meters, and etc., etc. But these are the things probably you can think of. And education, these are the challenges today. Again, I don't want to go very detailed. You can always ping me during this session or probably after this. So this is adaptive learning tools for customized learning. So we are still using very traditional mechanism. So we suggested something to AP government that we will put a camera in every class, and then we will detect the mood of the student. Okay, so if some people are active and then they are sort of in sync with what teacher was talking about, but some students they are probably looking there and here, or probably they are sleeping, or probably there are so many things. So with that we will understand, first of all, attendance, can take it directly from there, and then also we can see the emotions of people or kids from those class, and then probably we can do a personalized counseling of those kids. How best we can help this kid to bring onto the natural course of the class, right? So there's so many things we can do. And also we proposed it to one of the African country. Today you write a lot of examinations with the paper and pen. So in India also, right, after examinations, there are too much of buzz around. We need to move all the teachers to a central place, or probably district centers, and then we have to give them accommodation, food, and then transport facility, and then those guys will go there and then correct the papers, right? So can we automate it? Can, by using a OCR and then artificial intelligence, can we auto correct those papers? It's difficult, because we have infinite number of handwritings. Okay, so it's very difficult, but we proposed that, and then one of my student in South Africa, he is implementing in his in a school. Okay, so some of those things, like predictive tools to inform preemptive action for students. So all those things, many things we can do with respect to education. So this is my area, so current hour area. So as I told you, like approximately 45% of the people are living in urban, and expected 60% by 2050. I'm sorry, I said probably 20 years or so, but it is 2050. And 100 smart cities identified in India, and then L&T is actually working with more than 20 plus cities. Okay, so it's the basic things is all about crimes and traffic are the major problems in any of the cities. So we are predominantly dealing in those areas. Okay, so because with the interest of time, so I want to go a little fast. So this also I discussed earlier, like how we can improve overall mobility within a city. So assisted vehicle technology. Say, for example, today we are doing one work for Telangana Police. We are trying to create a green corridor for ambulances. So today, unfortunately, in a signal, at a signal, once vehicles are accumulated, then there is no way this ambulance vehicle can move out of that. People moving 1 inch there and here, but that's not going to solve any problem, because even they don't have a choice to give a way to these ambulances. So now we are integrating the ambulance. We're giving an app to ambulance, and then we track the ambulance through the GPS location. And we know that from which location to which location this guy is going, either for picking up the patient or taking the patient to a nearby hospital, right? So all those routes anyway will be decided beforehand, and then for those routes, within 250 to 300 meters away of this ambulance, so we automatically instruct these signals to give a green to this route where this ambulance is going, so that we can definitely save that we are planning to do something by 26th of January as part of our Republic Day inauguration. So we are planning to do that for Hyderabad Police. Okay, So that is a request from the IT minister in one of our demo. So he said that because we are already doing the petrol vehicles already. So he said that, why don't you guys do, the ambulances, which will save some lives. So then that is a great idea. So we are working on that. Okay, so let's have a little technical touch here. So as for me, okay, this is my personal opinion based on various sessions I taken across various forums, and I do take some sessions in some institutions, both voluntary and probably from the commercial way. So these are all the things what I feel we can classify things. Okay, it's all about descriptive analytics. We talks about the basic stats, about the data, right? About standard deviation, variance of that. It's all about data, understanding the data, what distribution it is following, etc. And the prescriptive analytics is all about a prescription. So hope most of you are aware, we call that as an operational research models, right? So if you go to a doctor with my problems, and then he will prescribe, okay, but do this, do this, do this, your problem will get sorted out. Like that, any manufacturing company will come to you, boss, I have my labor constraint, I have my logistics constraints, I have my production capacity constraint, but I have to meet the demand. So this is what my problems, can you prescribe something? Yes. So prescriptive analytics is all about taking all these constraints into consideration, and then it will give a an approach which will either meeting the demand or reducing the cost or improving something. Okay, I think you are all aware of that. So we have various models, linear model, non-linear model, etc. And then when it comes to regression, so predominantly people talk about linear regression and will stop. Okay, but I think most of you probably from some statistical background, so you may understand, there are a number of algorithms available in the regression itself. Okay, so Poisson distribution based regression or negative binomial, zero inflated, Huddle models. Then when you go down, so it is all about survival models, where they will use it in uh, actuaries, right? In the life insurance industry particularly, they will use all these survival analytics. So all last three are predominantly survival analytics related. Okay, and then time series, I think most of you are aware, autoregressive model, moving average or Riemann model, neural networks also playing a role in time series now. And classification, if I show you a cat, whether it is a cat or dog, so there is a sort of a classification, model. So we have, these are all very traditional models, logistic, multinomial or Navy Bayes or Gaussian mixture, decision tree, SVM, KNN, ensemble models. So many things are there. And here also neural networks will be used. I didn't put that, but neural networks is predominantly being used in classifying models. And deep learning, so it's all about neural networks based. And then now we are all talking about convolution neural network, recursive neural networks, and long short-term, memory based neural networks. Because you might have encountered, like, while typing your Gmail, so it automatically gives you the next word, right? So it's all based on LSTM, because it will store the context of your previous the words of the sentence, and it automatically suggests you the next word. Okay, so most of the time the word is correct. Okay, so those are that is a focus area today, because there are a lot of research is still going on, particularly with respect to understanding the text, and then conversations, human conversations, etc. Right? The chatbots, what I was talking about. So heavy research is still going on. And then when it comes to unsupervised learning, so as such, there is no class variable available here, but we have a bunch of data. So what to do with that data? So you can detect some patterns, and then probably that will be useful either for your marketing campaign, or probably you understand how based on what attributes you can classify something. Okay, etc. And dimension reduction techniques, I think we might have aware, I have 100 features available for me to predict something, but definitely 100 features if you are using, so probably you are overfitting, and then probably your model is so sensitive to each of these variables. So we always prefer a less number of features, probably south of 10, like 10 or less than 10. So converting 100 variables into 10 variables will actually gives you a production ready models rather than using 100 models. I think probably we still use 100 features in a very high sophisticated medical field, or probably environmental study, or probably the geology study and all. But for the normal traditional simple sales forecast and all, I don't think so you have to use 100 features, right? So recommendation systems like Amazon and also, they will give, if you buy one thing, so they keep on recommending the similar thing, so that it's easy for you to see the related items, and for them it's all about money, business, market basket analysis, page ranking, etc. And then there is one more very great scope in the future, the days coming in reinforcement learning, because deep learning is always very expensive, because you need a huge amounts of data, and then data is itself is a problem. But once you have the data, then we have to train that. Predominantly this data is not in the structured format, so you may be getting millions of images, so you need a huge computational power to process that. So obviously it will be very difficult to get that level of ecosystem. So probably reinforcement learning is a little slow to get the knowledge, but this is the place where we are also planning to use reinforcement learning for our traffic congestions in Hyderabad. We are actually working on that, not yet out. So this is an ecosystem of algorithms and then their high level classification, so that I thought probably for majority of the students it will give some synopsis. You may question, but Shala, this is covering everything, but it's covering good amount of models, okay, for sure. Okay, thank you. Okay, so I will share this deck to you, no issues. Okay, so these are the use cases we are talking about. What happened? Okay, so these are the use cases we are working. So we implemented a social distancing use case for Hyderabad, and Prayagraj, and Nagpur, and one more Raipur. So these are the places we adopted these both social distancing and mask. And pothole detection, see, in the city like Hyderabad, the average, the radius, if you go to the center point, the radius will be 50 kilometers, say for example. Okay, so 50-kilometer radius means you can understand the the area by r square, right? So that much distance, the area. So it is very difficult for municipal agencies to go to each and every road and then check whether any potholes are there. So it's a problem, right? So they have to carry the material as well if at all they want to fix it on the spot. So what we'll do is, like, we have almost more than 10,000 cameras owned by the police, and then there are about 150,000 cameras from various communities, right? In a colonies and probably near temples or probably near malls, and also there will be a lot of cameras facing outside of the mall, say for example. So we take all those camera images, feeds, and then we'll detect are there any potholes, and we send the report to them every week based on their commissionerate. Okay, so we have 3 commissionerates in Hyderabad, Cyberabad, and Rayadurgam. These are the 3 commissioners. So a report will go to them. Okay, this is the camera place, and this is the area, and I found 3 potholes. Okay, and a date, etc. Okay, so they know that where this camera is. So camera is connected to a police station jurisdiction. Can you go on mute if somebody? Okay, so
participants kindly go on mute. Shruti?
This is a pothole detection by using. Okay, so pothole detection, so we can save a lot of time and money. Okay, so this is already implemented in Hyderabad, done by my team. And water body encroachment detection. So as you know that if there is a lake, over a period of time, somebody keep on occupying the lake, and then they build some some buildings overnight or some walls overnight. So by using satellite images, every month or every 3 months, we can actually detect what was the area of this water body last week or last month and what is now. So that, every month or 2 months or 3 months, based on the configuration what we put, so they keep on getting the information. So the moment the amount is reduced, so then obviously people will people will go, officials will go there and then probably question them and then probably demolish before they construct something, and then people are started living there, so there is a legal problems, a lot of other nuisance will be there. Okay, so this is also we adopted for Hyderabad. This is all done by our team. And petrol route recommendation optimization. So as you know, petrol cars, and then if I'm not wrong, 3 or 4 bikes. Okay, so we will recommend which areas they're supposed to go and then do the patrolling. Okay, based on the historical crime areas. Okay, so we cluster various crime patterns, and then we'll give them, okay, these are the points you're supposed to go, and also we give them the optimized route, okay, to save their petrol as well, because government themselves short of money. I think we're all aware of that. So it will save some time or some money for them by reducing their fuel cost. So it is all about recommending the route. Okay, boss, go to these points like this, and also we optimize this route by using optimization techniques what I was talking about, operational research models, because this is completely a geospatial analytics. Okay, because I have to have the road network of the entire city. Based on that, I will perform this route optimization. And the criminal activity over social media and link analysis. So every criminal, though we feel that why they will be active in social media, but as per police, they are very, very active in social media. So if we can correlate the information, intelligence information what police have, and then connect that information with the social media. So today we are connecting almost 5-6 channels in the sense Twitter, Facebook, Instagram, and YouTube, and print media like newspapers and all. Automatically we read, and then we'll give them the topics, what people are talking about, or what these newspapers are actually talking about. Okay, so this is all about the social media criminal activity. And crime detection prediction forecast, this is a traditional one. So it will talk about if a particular area of the city, there is a lot of there are a lot of chain snatching incidents are happening historically. Okay, and so we have the data of almost 150,000 criminal data, okay, in the Hyderabad alone. Okay, Hyderabad in Telangana. So we have all their faces, and we have all their videos, like how they walk, how they move. So based on that, we will detect if any incident happens, we will find the similar incidents happen, and who are all connected to that those earlier incidents, whether they are in the jail or not. So if they are not in jail, so probably we will find out in the top 5-6 people, and then we'll go and question them. Okay, so like that, you can it will be very useful for the investigators to get the leads. I'm not saying that this AI will directly solve the problem, but it will assist various parties of the police, either investigator or probably the patrol officer, like we call them as a first responders. Okay, or the people who is actually sitting in the police station, we call that SHOs, station head office officer. And then some people will be sitting in the control rooms, like there will be a central control room, and there will be control rooms across various commissionerates. So these are the various stakeholders of this, and then we will give them contextual information to these people so that they will take the right decisions. Traffic signal optimization, I think we are talking about. So we hired one traffic person who is an expert in traffic, because domain is very important if at all you want to adopt any data science topics, because data science will give you some tools and techniques at the end of the day, right? So how that can be leveraged for a particular domain problem. So we need a domain expertise as well. So that's the traffic is itself is a big domain. So where we cannot try to train ourselves become a traffic expert. So that's why we hired a traffic expert, so that he will give us the guidance that how these traffic signals work, how the traffic planning happens, etc. So finally we'll use the right techniques to solve some problems. And if something cannot be solved, so probably you have to go to the police and then say that boss, you have to put a flyover probably, or probably you have to put a U-turn somewhere, or probably you have to stop a U-turn somewhere. So those are the recommendations we'll give. Flood detection simulation, we did it in for Pune, because Pune every year there will be a flash floods. So by using satellite images again here, so all it is elevation model. So and we have the almost 30-40 sensors are there across alongside the canal. As part of our smart city initiative, we already did that. So we are leveraging that sensor data and then see how the sensor level or water level will increase for certain amount of rainfall, or how this will increase for a certain amount of water discharge coming from the nearby dams. Okay, there are 3 dams outside of the Pune. So we have the data around how they will discharge the water, and then if they discharge say 1000 cusecs, what will be the level increases at a particular sensor, so that we will simulate the model. Okay, if this goes to a 10 meters 10 centimeters more than the normal, then we know that which areas around that particular point will get flooded based on the elevation model. And image quality, as I said, India, the videos images are not so great. So before we apply any methodology, so we first try to enhance the image before we apply any algorithm on top of it, so that you will get a better accuracy. Video sets, so for example, I told you, right, there are 10,000 cameras there in Hyderabad. They will store continuous video data for last 30 days. Now, if at all I want to find out, I want to find out a red color car between in a particular day around a particular area, then somebody has to go to those videos, and then they have to manually check it. But what we will do is we will take that particular camera recorded video, and then we will give them the metadata, in the sense that every frame we will say that okay, these many people are there, and out of these many people there are 3 people are adults and 2 are female, and 3 are kids, or probably 2 are old. And then also we'll tell them that okay, these are the 10 vehicles we detected. Out of that, 2 buses and 1 truck, or probably 3 cars, and then 2 autos, or probably 10 bikes, for example. And then not only that, it will also detect what is the color of each of these car, or color of each of these vehicles. Okay, whether somebody is wearing helmet or not. Okay, are there any special mentions there behind the car or front of the car? Somebody says that my dad's gift or my God's gift and whatever, right? So we can also detect those things, so that will be easy for us to identify the car. And once we identify the car, then we will pull the data from RTA that okay, who owns it. Okay, and then we have number plate recognition cameras across the city. Then we will detect okay, where all this guy is traveled for last 10 days. So it's a complete 360-degree view of a particular incident. So it will be very easy for any police or investigator to speed up the process. Okay, etc. Okay, so this is some of the things we did, as I told you in my previous. So this is how we detect a person coming closer. So it says that we are not maintaining a minimum distance required. Then automatically it gives red signal. So for every red it comes in, so that the red image will be stored in my database. Okay, and all these things will be sent to the police station automatically. Take all the last 1 hour's data, and then we'll say that okay, particularly this area of the signal, this signal, there are people are not following the social distancing. But compare this with other cameras, because this is all camera video, okay, CCTV. So we will take the live system and then automatically put the bounding boxes and then make that as a red if somebody is not maintaining the social distance. Okay, so all this information will go to the respective police stations, and then we are not detecting, because we cannot penalize. We don't know who are these people. Okay, we are only saying police that okay, this is the area where you have to have a more vigilance. and then spread that awareness that COVID is a dangerous disease. So, but prevention is better than cure, right? So that that will give awareness. Okay, so police will be deployed in these areas. So this is some of the challenges what we face. Video quality is always a problem. Technology stack is a simple, straightforward. Is a we use a Python, and then we use a big data based ecosystem we have. So we store all these things in our HDFS type of big data ecosystem. And but only thing is that the challenges are numerous because of the quality is not good. And if I talk about 10,000 cameras, then each camera will produce 25 frames per second. So my system supposed to process 10,000 into 25. So it's almost how much? 2.5 lakh images. Each image is of 2 MB size. Now you can understand the ecosystem required to process that, because it's not about backend process. It has to process and it has to immediately detect. Okay, so it requires a lot of ecosystem. So we spoke to Intel directly, Intel US, to see is there any optimization possible. So they gave us some suggestions, but nobody did these type of things at this scale, to be frank. So we are keep talking to various foreign chip makers to see how best you can do that. Okay, so this is a face detection. This is also same. So this is I don't know, people are waiting for in front of the wine shop, I don't know, but these guys are we detect who is wearing the mask, who is not wearing the mask. Here also the objective is not to identify the person, it is identify the number of such instances where people are not wearing the mask. Okay, we are not storing anybody faces. Okay, because that is not quite right to detect to store the faces, because even I cannot even see the faces, right? Because you get very small faces, because it's a CCTV camera installed at a very, I don't know, the 12 meters or 12 feet, 12 meters if I'm not wrong. So it is very difficult to get it, but our idea is to get, so for such a small face, we able to detect whether somebody is wearing the mask. But this has to go through some process to further improve it. So we achieved around 75 or 75 in our first instance, and then we keep doing the so-called transfer learning in our analytics, particularly in the AI space. So with that, we continuously improve the performance or accuracy. We call that as precision, recall, or FN score, etc. So here also same problem. Size of the human face on CCTV camera is very small. In that small, we need to find out the mask. And India, if you see, the masks are very innovative. Like somebody, females, they put their sari, or probably the farmers, they will put some towel, and probably some people will put some various colors and then shapes and sizes, right? So it's not quite that easy for any algorithm to pick up all varieties. So this is a water body encroachment I was talking about. So this is entire Hyderabad. So we have these many water bodies are there because Hyderabad is a land of lakes. We call earlier when Nizams were ruling Hyderabad, everywhere they created artificial lakes. But the majority of those lakes gone because of this urbanization. So if you see this particular area, this entire red is gone. Because red means they urbanized. Okay. So this is what we used. We used the last 20 years of satellite data with 30 meters accuracy because it's all open source. Because we as an organization generally don't go for any paid licenses, right? Otherwise, it will be very expensive for me to sell it, and then probably the governments or customers also may not buy it because of various licensing agreements. So our first priority is always go with the open source. So it's not that because L&T we can do something, you cannot do that, because we are also using the open source only. Okay, nothing more, nothing less. But of course we have many systems available. Probably I get 100 core system quickly, or probably 10 TB 20 TB of space, I will get it quickly. or probably 128 GB or 256 GB and all also I get on demand because I have my own data center. So that is the only difference. But technology accessibility, I think whatever I have, you also have it. Okay? So we use a vegetation index or bare land index. So there are techniques available to detect to work on satellite imagery, right? So those are the techniques we used. And this is a pothole detection. So during the COVID, luckily we leveraged, because hardly anybody you can find on the roads. If the vehicles are passing, then obviously it is difficult to detect the potholes. But even today also we do it in the early morning time where I have a sufficient light, but with as less traffic or human activity on roads, so that we'll get a better one. Okay, so this is how we detect the potholes. This is detected by model, so it will give various metrics. Okay, so challenges, I think we discussed quite elaborate. Quality of the data, first of all, data is not available, and then once you have the data, quality of the data is a challenge. Infrastructure availability, because though I'm talking about almost 150,000 cameras, but that only covers some area, right? Because if you see where I'm detecting that either potholes or probably social distancing, that is only covering probably 200 square meters or probably 400 square meters, not more than that. So I can only do something where cameras are installed. Okay, because why we are doing that is, at least without any additional infrastructure, we are just giving a software so that they will get the benefit out of it with the existing infrastructure. Okay, but fortunately, India, Hyderabad and Chennai are the top two cities in the world where the per capita cameras are high. Compared to, even you talk about Beijing or probably China uses a lot this type of things, but we are much ahead of them when it comes to the number of cameras, coverage, and for every 100 people, how many cameras we are using. So in all those statistical measures, so Chennai is the first, if I'm not wrong. In the recent metrics, I think last week, I think they published in local newspaper, and Hyderabad is the second one. And then government also investing heavily on adding more and more cameras possible, so that it will be very easy to do a lot of things centrally. Okay, so it requires a commitment and investment, so there is no doubt about it. And internet bandwidth, so I'm talking about 10,000 cameras or 150,000 cameras giving 2 MB of frames per second, then what is the bandwidth required? So that's the reason we are changing our strategy to do edge computing. I think you might have aware that. So the camera itself having a device, a chip, I will deploy my model there directly. Okay, so model is actually running there at the edge, at the camera, and that also stores at least a week's of data. Okay, and if it detects something, only that detection part will be shared with me to the center, so that I can manage my bandwidth very effectively with that. So we signed an agreement almost with Western Digital, which is one of the very big institute, one of the big company in US. So they do all this edge computing, and then we do our use cases on top of it. So that's where we are trying to achieve our objectives. And ethical aspects, the fairness, privacy, accountability, transparency, these are all still problem, because it's purely based on the old history. Because if you see in the US, there is always a biasing against the black people, say for example, right? So all the historical judgments are with that bias. So if I take that data and then train my model also will be biased. Okay, so that is a problem. And also, if artificial intelligence taking a decision in judging something, so how we can explain that to the victims, or to the suspects, okay, or to the public, that okay, based on these reasons, I am imprisoning you for next 7 years or 10 years. So the explainability of the model is also very, very important. So that is a reason is still not very effectively being used in the public space. Okay, so quickly, these are the skills I expect at least from the data scientist. The green items are predominantly we will get it in general, but these white items are generally we don't get it. So that's what my suggestion to all the students, who are actually want to pursue this data science career, if at all. I expect that people to understand the DevOps related AI ML techniques or model optimization. Your model gives a great result, but it should work for 150,000 cameras. That is a volume of data it's coming. Whether your model is sustainable to meet that type of load. Okay, so that is where you need to optimize your model, because it doesn't mean that if I have 10,000 neurons in my neural network means that it is a great. No, I want the minimum neurons in my network so that the number of weights will be less and the number of the training will be very easy, and also it is a very easy or simple or fast enough while predicting something once I move this to production. Okay, so optimization is important. Model validation still okay, but people comes with non-statistical background, so they are not quite effective in validating their own model. Okay, but otherwise models are available, and if you Google it, you will get a model. But what to do with that? How to adopt that? Whether that can be directly leveraged, or probably we need to do some sort of a transfer learning, or you need to change that network. Okay, so 99% of the data scientists, they don't do any fresh neural networks for your information. They will only take something from the internet. So there are so many nets are available: ImageNet, ResNet, or MobileNet, or there are so many. YOLO, 3, 4, 5 is available now. So there are so many networks are available in the market. So they will simply take it and then they tailor it for your business problem, try to solve it. Okay, but nobody experienced enough to go at the neurons level and then create their own network. Okay, I doubt, based on my knowledge, my experience with my teams, and then my network. So model is great, but the model is supposed to be usable enough, right? So usability of this model will be purely based on your user interface design. Okay, so though that is not a primary responsibility of the data scientist, but I still feel that they should have that mindset that how user will interact with the model. Okay, so that it's supposed to be easy, and then it's supposed to be with the less number of clicks if they get their output. That is where we need to think. So that is where problem definition and visualize the outcome and usability is very important. So that is still a big problem, because everybody wants to do neural networks, but they don't know why they are doing it and what for they are doing it. And then some basic idea about retraining, feedback mechanism, and then basic databases, warehouse, smarts, lakes, and all. I think that is a standard matured area, so I don't worry much about it. And then of course knowledge about Linux, Ubuntu type thing, where you can deploy your model, running your model, or training your model. So this is a little old framework because I don't want to disclose something what we are doing, but some standard template probably will be useful for any person who want to create end-to-end use case. So these are the things we require: data acquisition, raw data, cleaning data, data annotation, cleaning, and then training of your model, and then your code, and then model version control, and then model inference. Inference is all about the deployment, and then finally that deployed version will be accessed through your front end. Okay, something like that. So it's a high level ecosystem. There's nothing great about it. So this is pretty much covering what I want to talk. So it is probably too much talk. Hope this will be useful. Now it's open for any questions, if at all. I think we have 4 or 5 minutes left.
Dear participants, if you have any queries, you can either type in the chat window or you may unmute and ask directly.
Okay, so I'm very active in LinkedIn. So if at all you want to be in touch with me for anything, so please in touch with me. Just search for Tadigmala. I don't remember the exact this one, but you can always connect with me. Okay. Because definitely I would like to have a synergies between the institutions and then companies like us, so that because even I do a lot of opportunities to a lot of people, those who are doing their third year, final year, to do some sort of an intern with us, so that I will give the real use case, so that it's a win-win situation where you can get the real-time situation. Because whatever you are doing in the lab, I'm sorry to say that that is only a lab. Okay, that is only a theory.